Let's start the boost. Let's get it going. I'm a little bit late today, so I'm going to jump right in. We're going to get it going. We're going to be doing more bash today. So, how's it going? Hello. Hill who? So we were working on discrete. Oops. We were working on the discrete program last time. That's interesting. What's going on? Did I interrupt something there? I just started this VM, so it might be having problems still. All right. So this is where we were last time. We were writing bash, and I spent a lot of time talking about, the nature of programming and then what everything is called, and how programming from bash is really just putting commands from the command line into a file. And so we're ready to go forward and do some more stuff with this. And we're actually going to write some code today that you might find more useful than just hello world. But I did want to get you kind of, acquainted with everything. We talked about all of the resources. So if you've gone through all of those things, you already know, where we're at. And we're just getting ready to make scripts. Now, the goal of the bash and the boost is really just to get you able to write your own configuration files, to create your own Unix filters, and to understand more complex bash code. We are not going to get into the nitty gritty of everything that's in the bash man page. And, as I put it here in the related section last week, you can go into man bash at any time and you can see everything. And I encourage you to do that if you're a veteran. So we get people in the boost who, are not beginners, that just kind of want to check their gaps and stuff. And for you, I want to strongly encourage that you just literally take, some time each day or week or whatever, and just read everything in the bash man page. There's a bunch of things here that you want to understand, but then you can kind of use that as your basis for research. And then you can go do internet searches based on that. Okay. So given that, the first things that we're going to write with bash, the very, very first things we're going to write is just basic script. We already did the greet program, and we talked about arguments and parameters and the difference between them. And we talked about different forms of expansion, including this expansion, command expansion. And so that's where we are. Okay. And again, so today, just to kind of give you the prelim of today, everything is going to be about making quick and dirty scripts that will make you better at using VI, that will make you better at using pipelines, and how to manage that and where to put them. So the first thing we need to talk about is, where do I start to keep all these things? Because we're going to write a few of them probably today. So we're on week 10. Let's go ahead and make 10. This is all in the boost. If you don't know where that is, you can go look everything up in the boost directory. And that's where this is all going. And we're going to go into week 10. And we'll make a README here. Actually, let's just copy the README from 9. And all these commands we've already covered. So, go back and watch that. I realized that, we're being on week 10, 10 times 5, that's 50 hours of work of editing. But, if you were to go to a boot camp, what am I doing here? I got to think about what I'm doing. Actually, I don't. Well, I guess I could do it. No, let's just copy the. If you were to do a boot camp, morning from the West Coast. Hey, hi. So if you were to do a boot camp, you would be putting in 40 hours a week minimum for 8 weeks. I want everybody to realize this, because I sometimes get responses from people that are like, will I be able to get a job and everything? I'm like, well, I don't know. Have you been spending 40 hours a week practicing for all this time? Like, wow, it's taking so long. It's like week 9 or 10. I don't want people to get frustrated, but I do want to spend a moment before we get into this talking about this. This stuff just doesn't happen. You have to practice it, right? That means you got to put this as a priority above other things. And this 5 hours, if you don't have that time, if you can just allocate 5 hours, that's why I'm going so slowly, is because I'm doing everything with you. So you can sit next to me and we can like work on it together. And by the way, don't feel bad. I mean, about 90% at least of the people that have been through my mentor program, SKILSTAK, that I started in 2013, about 90% of them had no time other than their 1 hour a week with me to work on anything. And so their progress was very slow. Most of them, it took them 4 or 5 years, but they ended up doing crazy, amazing things after that. How can you go catch up? You could probably go back and start watching the Boost videos. They're also on YouTube. So if you go on YouTube, it's my top playlist, and you go watch that, and you go from there. Every time, this is something I learned with the other people that I mentor. I've mentored people for a long time. We've almost finished the entire summer. So we started at the beginning of summer. We started in May, and here we are, almost entering August, and we're still doing this but if you think about it, if you count the number of hours you put in about 4 hours. So 1 to 5 is 4, right? 4 hours a week. So I actually did the math wrong. So four hours a week for 9 weeks. 4 times 9, what is that? Oh, so looking forward to the 5 hour sessions. Then spending, let's see, 1, 2, 3, 4, 1 to 2, 2 to 3, 4. I can count. This is what you get when you get unedited content. You get Mr. Rob doesn't even know how to count. So we've been doing 4 hours. You know what? 4 hours is perfect, right? We kind of go over a little bit sometimes. That's 36. Yay. For me, it's early. I stayed up till 5 a.m. this morning, cleaning my room and working on my IRL stuff. So, but I'm super excited for the Boost today because we're going to get to code in one of my favorite languages, Bash. So let's go ahead and put it in here. And of course, I'm lazy, which means that anytime I can write a script for something, I will, if it means that I don't have to do it again later. All right, so this is week 10, so let's change this to 10. Hey, see the magic of, watch. Hey, what's the command to delete the paragraph? Let's do a little bit of quizzing. What are the keystrokes to delete an entire paragraph? Up to the next blank line. We actually made a big deal about this one in VI. DAP, yes. There we go, right? So I can leave this section, but I want to get rid of this part. DAP that thing. Right, here we go, DAP. So you can do DAP, or you can do D dollar too. Actually, no, D dollar will delete. I think that'll only delete till the end of the line, right? Yeah, because dollar is the end of the line. So yeah, DAP, just to make sure you know. So yeah, this week is all about coding useful scripts and configurations in Bash. If we do this right, we won't have another day of Bash. This will be the only day. You have any answer? Exactly. I know, because maths, So what is the goal? The goal of today, we had to do a little bit of CSE kind of things and Unix, philosophy stuff last week and the week before. This week, by the end, you should be able to do 2 things. All right. So goals. So the goals are 1, and you can't really number things in the descriptions. I wish you could. I'm going to try anyway. 1, be able to configure your Bash interactive login environment or shell, whatever you want to call it. That should be the first goal. And 2, you should be able to, we did Markdown, right? To create, well, why do we have to have this wordiness? Let's get rid of that. Oh, how did I do that? How do I delete the words? How do I delete 3 words in a row? A little bit of review. How do I delete 3 words in a row? Somebody want to try? I'll give it to you. D3W or DW3 or 3DW, any of those, right? D3, or you could just do DW period. How about that one? That's what I do because I'm lazy. I don't like counting. So I'm like, I like DW period, 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 wide period. What does period do? Period repeats the last thing. So I like that if I know I'm going to be doing something a lot. All right. So I should put the thing on the screen so you can see, but whatever. So, I don't, honestly, I'm serious. It's all about laziness. I am too lazy to look at how many words are there. Plus, I probably want to do it again. What's the problem? See, this is the kind of thing you're not going to learn from a book. DAP deletes the current paragraph to the next blank line. DAP, boom. See that? All right. So, and what if I seriously, if I done D3W, what's the problem? I mean, I want to talk about these things when they occur to me, because these are things that are not covered in books because they're practical, right? So D3W might get me exactly what I want to need, but then can I use D3W down here too? Kind of. Be able, you know what I mean? So this is what I tend to do. I tend to keep things small and modular. Even in my own VI sessions, I practice Unix philosophy. I do something small. So like do DW, and I like, okay, I need 2 more deleted there. I need 1 here, 2 here. And the thing is, if I was going to delete 2 words on the next line, I still have it queued up in my dot. So if I know I'm going to be deleting paragraphs, I DAP. Even if it's 5 paragraphs, I DAP, and then I period, period, period. I go, oh, here's another one, period. And you just repeats the last thing. So here's the dirty truth. Most people, in my opinion, do not use all of the fancy ass numbering compared with VI. If you can combine, I'm gonna put that in tips section. Tips. Get good with basic Vim commands and just repeat with dot. It is way faster to do that, because let's say like, oh, hey, there's a word up here I need to get rid of, dot. Well, can't do it there because I just inserted over here, right? So let's say DW, right? Oh, I want this one gone too. Okay, I'm deleting it when I'm doing that. I did 2 undos instead of the whole line. Why? Same reason. Same reason. Sometimes I don't want to undo the whole line. So I got to tell you, of all the stuff that we went through in the Vim tutorial, of all that stuff, I probably use 20% of it, because it's just too much work to do all the other stuff. And there are going to be a lot of VI purists out there who are going to give me crap about that. I don't care. I'm far more efficient. Like, there's one. How do I uppercase this letter? How do I convert that letter to uppercase? It's a very useful thing. I use this all the time. Right? I want to make that uppercase. How do I do it? Anybody? We don't have enough people here yet. Anybody? How do I make it uppercase? How do I fold the case in ASCII? Yeah. That. Right? I come down here. How can I do that same command again? How can I do this? Yep, you got it. Now, how do I repeat it? Yeah, that's way too hard. How do I make this C bigger again too? I can do the same command, or I can push dot. Let's say I want to capitalize this entire word. Dot, 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 dot. Let's go over here. How do I want to make this useful? Dot, 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 dot. Why is it capitalizing? I'm doing it with one hand. This other hand is drinking coffee. Dot, 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 dot. Why? Because it remembered. Watch, by the way, I can take the case down again, right? Because it folds the case. My point is, get good with like the basic, most common things that you do, and then always hit that period. It's easy to hit the period too, by the way, with your pinky finger over here. So, this whole repeat 3 times stuff, no, I don't do it. If you want to do it, that's fine. But it's going to take you forever. So anyway, configure your bash and interactive login. That was kind of a big tangent, but when I think of these things, I want to make sure I cover them. I mean, seriously, that is not the kind of thing you'll ever read in a book or a Vim tutorial. And you'll play Vim Adventures and learn all this completely useless crap. And it would have been better for you to just learn how to use dot or filters. The all powerful bang bang. So anyway, create Unix filter scripts for use in pipelines and for use for Vim and pipeline. What's a pipeline? Should we get going? Let's just get into it. But think about it. If somebody wants to answer the questions while I'm doing it. All right. So we need to be able to log in and configure your interactive shell. All right. So, but before we do that, we still need to understand the basics of understand. There's actually a cooler word to say understand in the tech world. It's called grok. Anybody know where the word grok came from? Grok, basic bash syntax. All right. How do you do that? How do you do that? Hey, you see that? It fixed my lines. I used a pipeline. How did I do that? Oh, look, my numbers are all messed up. Oh, no, whatever will I do? Maybe this one's a 2 and this one's a 3. However will I fix those numbers? Unix filters to the rescue. Man, I could even have it be 5. Watch this. All right, so here's my command. Reverse proxy. Grok, I don't, we're going to find out. So watch. Bang, bang, right? Actually, bang, bang, right brace. And I send it to my cool filter called TXT. All it does is convert markdown into text, which automatically fixes and spaces. Isn't that cool? That's cool, huh? If I want to, I can do it with pandoc. So again, filter. What's in the TXT command? This is the kind of thing we're going to make today. You don't know about pandoc yet. We're going to learn it. But all I did is I said, look, I want to take all of the input, run it through pandoc plain, and don't do any wrapping, and then spit the output back out. No, I don't even need to sort there. I don't need to sort. I wanted to actually keep him in that order and fix the numbers. So a little bit different thing. But yeah, you could use that. You could use sort if you wanted to sort them. You definitely could. Let's try that. How about we do that? Sort. Oh, hold up a minute. How awesome is that? How awesome is that? All right, ready? Bang, bang paragraph, bang whatever, bang brace. How about that? Bang brace. We'll say bang brace. Bang brace is another thing I do all the time. Sort. Boom. Okay, this is the proper use of VI, according to me. So we're going to grok the basic bash syntax. I'm having so much fun teaching you Vim stuff because God I knows I love it. Configure your bash interactive login shell, create Unix filter scripts. Okay, so let's go through the basics of bash. First of all, let's talk about what grok means. So what does grok mean? Anybody who wants this VM, remember this VM, github.com/rdbxrob/boostvm. And you can install this VMware player just exactly like I have. You can actually copy out my MS terminal preview, which by the way is better than just regular. You want to get the preview. They just increase the speed. Yeah, they just fixed a bunch of problems with scrolling speed in the Microsoft terminal preview 2 weeks ago. So somebody just told me about that on Discord. I did it. It's totally true. They actually saw me in the boost running Sunrise. I was running Sunrise and they're like, why is it taking so long? And then they found out that they had been in optimization. So now it runs really fast, which is great. So if you haven't got the MS Terminal preview, and I mean preview, there's another one that's not the preview. You want the preview. The preview is the one that's always got the latest changes in it. The colors are messed up for reasons I won't get into at the moment, mostly because it still thinks it's 256 colors because of my tmux configuration. But tmux config is going to be a different day, not today. All right, so let's do a search. What does grok mean? Grok definition and meaning. The meaning of grok is to understand profoundly and intuitively. And this is in Merriam-Webster. That means, is it going to tell us the origin? I know I'm all over the board. I told you, everybody who's annoyed by my style, I'm sorry. This is how I mentor. I just kind of let it flow, have a general idea, and just let it go. Verb, how to pronounce grok. Grokking, grok. Definition of grok. Grok is a transitive verb. We did navigating with links. We already did this. So synonyms: appreciate, append, to hold, behind, blah, blah, blah. So grok basically means to get it. It means to really get it, not just the definition, but also like to know why it's important. That's a grok. And if I remember right, it was Heinlein who used it on Marsha. Yep, here it is. Yep, there it is. I got it. I remembered right. Yay! It's from the Heinlein novels. Yes, absolutely is. Grok is maybe the only English word derived from Martian. Yes, we do mean the language of planet Mars. No, we're not getting spacey. We've just ventured into the realm of science fiction. Grok was introduced by Robert A. Heinlein, 1961 science fiction novel Stranger in the Land. So this isn't just a boomer word. You're going to find Grok all over the place. And it's actually nice because it's much easier to type than understand. So it's kind of an action verb. It is transitive, so. Okay, so if you haven't ever seen that word, particularly if you're not like an English speaker or something, right? Am I in the wrong thing? Where am I? Where am I? I need to reset my TMUX. All right, so if you are, do we learn enough TMUX already? I think we did, right? We did navigation and TMUX. So I'm going to actually reset my TMUX by going into the directory 10. Now, you can put this stuff wherever you want while you're practicing your scripts, okay? However, I would like to encourage you right now, so let's do this, okay? I would like to encourage you right now to create a repo according to the organization. We're starting to make stuff that we want to keep now. Now, you probably have already got some way to take notes. You may or may not be taking your notes using VI. We have not covered Git and GitHub yet at all. We've covered Git. You can go into GitHub and you can like do things through the web interface. And now that you know VI, was the program? This is MS Terminal running Linux and a VM, and we're using VI. So, but I'm going to tell you something that you're ready for now. You weren't ready for this before. You're now ready to start organizing your artifacts, the things that you're making, your notes, the stuff that you're producing, right? And we're not ready to like get into saving stuff on GitHub and all of that yet. We did show you how to do that if you want to do that for note taking and learn Markdown. We did cover that like in the first or second week of the boost using the graphic web interface. But now that you know VI, and you should be starting to practice VI, it's probably good for you to start taking those notes in your VM and using VI for it, with the knowledge that eventually, you can save a backup of your VM. We've already talked about that. Actually, if you're using the player, I don't think you can, but it's there. But we're eventually going to show you how to take that directory and put that into GitHub, which is an absolute core skill that every technologist on planet Earth, if you are in the IT department in any capacity, including as an admin, or like somebody who does the HR stuff, you should know GitHub, Git and GitHub. You may not like the company, you may not like Microsoft, doesn't matter. You need to know it. Okay. So we're going to get there. We're not doing that today. All right. But the reason I'm telling you all of this is to preface the statement, thou shalt organize your stuff. That's really all I'm trying to say. So let's do it. Let's go ahead and start organizing our stuff. So the first thing I would do is go back to your home directory. By the way, if you're anywhere on the system, let's say I'm like in temp, what's the command to return to my home directory? What's the command to return to my home directory? Very simple command, 2 characters, two letters. CD. Yep. And if you've used CD dash like I did for 40 years, that's not true, probably 20 years. You don't need the dash. So, and by the way, the dash is not particularly easy to hit. Senor Het's time, danger of being classified as habitual Twitch time like so. No, Het knows that this has been my boost time since the dawn of the internet. I had this stuff organized before Het was a twinkle in Twitch's eye. I love Het. You should all go watch him, but if he's doing other things, go watch him. He's more advanced. I'm doing beginner stuff. All right, so CD into dot. CD into dot. What is actually? No, you're right. What does that do? This is the one. This is hard to hit, right? It's like, why would you do that? I did this. I swear to God, the senior admins taught me to do that, and I was like, and then one day I was like, so what's the difference between tilde and dot? I'm going to hit you with these like mini quizzes all the time to practice, test your knowledge. What's the difference between tilde and dot? Someone give us that answer really quick. Otherwise, I'll just tell you because I don't want to waste time. But if you're watching this on YouTube, you can think about it. What's the difference? You should know this by now. We covered this pretty well. All right. So yeah, dash takes you to the old PWD, which is an environment variable, which we haven't covered yet. But that means dash toggles. See how it toggles? There's also pop D and push D. We're not going to talk about that right now. All right. So cd tilde is just an alias for home, which is also an alias for home. We did variables briefly. We're going to do them again. So there. Okay. So you can be anywhere on the system. Just hit cd and that'll take you back home every time. If you want to go back to where you were, you can push dash. If you're in home both last times, then it just doesn't do anything. Okay. All right. So why are we home? Because we're going to create some stuff here. Now, so for the next 5 minutes, I'm going to tell you my way of doing it, but you make your own decisions. Okay. So I will tell you right now, when you get into this, so let's do find. Remember find? Find makes a really good recursive ls. If you don't have it, oh my God, look at all that stuff. Look at all that stuff. Let's do this. Let's do find repos and prune 3. Oh, what is it? Is it prune ls? I can't remember the command. You can use the existing, home. That's only if you have multi-user systems, but it's very rare to have that. But you absolutely can do that, yeah. How do you just show the first 3 levels of the directory? I can't remember. We can do type D for directories. That's like all the directories. I know depth. It's depth. It's depth 3, I think. Damn it. I can't remember my find command. All right, so I hit tab, depth. No, let's do depth 3. We're going to specify a global option depth after argument type. Oh, okay, depth 3. Paths must precede expressions. Paths must precede expressions. It must have to be here. I told you we're very live here. How do I? Is it max depth? I don't do that often, so this is a good one to make into a command. Hey Zeddy, so I mean we could also just do ls, but let's not. Is it max depth? No, that's not one. All I want is the directory, so that's D, right? And I only want the top 3. So how do we do that? Type, is it max depth? MA tab. Oh, it's MAX depth with no underscore 3. There, yay, we figured it out as a team. Thank you, you got it. Now that might be a fun alias to have, yeah? Right? We can make that into command. So let's actually use this as one of our first commands, okay? So I want to say, let's say, what could we name this? So I'm going to copy and paste this. So I'm using tmux to copy and paste. Actually, I don't have tmux on. So I'm not using tmux for the moment. I'm just going to use the mouse because I'm going to pretend I'm you. All right. So let's say we have that. Like, oh my God, I want to remember that one, right? So instead of repos, let's use dot. All right. So that's the current directory. I only want directories. And wow, that shows me all the directories at 3 levels down. Yeah. Nice. Okay, so let's do we could say dir 3 or something. So a little bit of review of last week. Here, I typed the command. I'm going to copy. I'm cheating. I'm using my mouse. All right, now I need to put it into a command. So right away we have questions, right? Like, where do I put this thing, right? Now, I've been putting my stuff in the boost directory, and I know that you think that's weird because I just cd'd right into the boost directory. That's magic from bash that most people don't know. Most Z shell users will tell you, oh, you can cd into anything and it'll know the right thing. It's because they don't know about cd path. We haven't learned it yet. I promise we're going to. So I'm going to go back into 10. I'm going to use this to put my scripts and stuff. But let's make a script. So what if I wanted to make a script? This is a review from last week. How do I make a script? And we'll get into our organization in just a second. I'm kind of switching gears. How do I make a script? What are the steps to making a script? And why should you not just start with VI? We covered this last week. So again, this is a review. If you don't know this, you want to go back and watch last week. Why are we touching it instead of, in the shortest possible terms, why are we touching it instead of, we're not putting a .sh on there. No. Do not use, look, Do not use suffixes in Unix and Linux. Promise me you won't. The only time for executable scripts, okay, you should never do that. Especially, it's just bad form. A lot of people do it, and everybody else hates them. Okay, I'm just gonna warn you. They'll think bad things about you behind your back if you do that, because you're forcing them to push dot whatever. I know they can do tab and blah blah blah, but there's no reason for it. You go, well, it's not gonna show the formatting right. That's because your Vim's misconfigured. All right. All right. So yes, you'll check to see if you have the permissions right in the folder. Exactly. So we're going to just touch, or we're going to do this. Either one is the same. So we're going to make, what should we call it? dir3. I'm going to say dir3. I mean, that's a stupid name, but I kind of want it so that when I type dir, I can type tab and pick one of the ones, right? It is kind of the same. It has the same effect, Patroclus. It will absolutely, yes, it will truncate existing files. Yes. And that's what we want in this case. But that's a good point. Thank you for saying so. Yeah. If you do, yeah, that will empty a file from bash only. No, I would never put any extension on any shell script ever in anything that's ever on any form of Unix. And if you're forcing command line users to type extensions, I think you're doing it wrong. I always have. I've hated it. There is no need for an extension. If it's good, because consider the fact that you're going to be putting it in your path somewhere and you're going to be forced to type that extension every time. You want the thing. And plus, what happens if you want to rewrite it and go? What do? Okay, I'm putting this in the notes because this is like a big thing, and people don't consider this stuff, right? Never use extensions on executables on Unix, Linux. And the script over an alias, last week's topic. Last week's topic is because you can watch. I'm going to show you. I'm actually going to, we covered alias versus script, but I am going to show you exactly why. All right. And you can make the decision. Maybe it's better as an alias. I don't use aliases and functions unless I am changing my currently running environment. That's the only time, because I can't use them as Vim filters. Let me show you. So, I mean, there is a way around it, but it's very convoluted and it's not natural on other systems. Whereas if you make it a script, you just put a script on the machine, you're good to go. So here we go. We have a dir3. We're going to schmox that, which now, by the way, this is an alias, right? Because that's nothing I would ever type. Schmox, my schmox is really lazy. It's just an alias, right? Me making in my test folder. Oh, God. No, just don't. Just take off the extensions. Seriously, the number one reason to not use an extension is you will regularly change your mind about what the implementation language is of your command executables. And if you force yourself into a single language, unless you want to do that, you're never going to be able to change it. If you want to swap it out because Perl's got better regex support and you started out in Python or Bash, that's a really important one. So let's say you start out in Bash and your program grows. Your program grows and you put .sh at the end of it, right? You put .sh, now you got it. Now it's hard coded into everything that you've used. All your other little scripts are calling it using that .sh. And then what? And you say, this regular expression matching right here could really use some of the later, I don't know, Unicode support in the current Perl regular, which is not in Bash. So I should probably add that. So you add it to the thing, and now you're got a problem because now you don't even know what extensions you've used. You have no idea where your .sh calls are from all your other stuff. You have to do an extensive find and grep to find all of the things. If you had just done the right thing in the beginning, which means make every executable a single name, an action, whatever you want to call it, then you wouldn't have this problem. You just change your shebang line at the top and nobody knows any better. It's a difference. It's called abstraction, like that encapsulation that's reusable. Let's say you want to make it an executable C program because you got this 5,000 line bash script that might be called Zet and you need to really rethink and rewrite and go. I'm looking at myself on that one, right? I mean, I got up to 5,000 lines or so in Zet and I'm like, I probably should rewrite this in an actual language besides just shell scripting language. So then what? I re-implement the whole thing in Go, put it exactly in the same place in the path. Actually, not even in the same place. It can be in any place of the path. And now all of my dependencies on that thing change. Putting .sh at the end of your thing is like writing a function. If you know how to code, it's like writing a function that has some dumb stuff at the end of the name that has to change because or using type whatever the Hungarian notation, which is so bad. Okay, that's enough on that rant. So, but there are times to use an alias, right? So we have an alias. So I need to schmod that. Schmox, because I'm lazy, I don't want to type +x. That's how lazy I am. So I have dir3 here, and in my paste buffer, I can paste my stuff. Now, as we talked about last week, this will work, right? Oh, I didn't find it. Why didn't it find it? This is a test for everybody. Why didn't it find it? Hi, Austria. Why didn't it find it? Go build that shell script. Never leave your home again. It's not in the path. How do I run it? Someone tell me. Someone tell me how I run this. I'm so sorry for the ads. They're only 30 seconds, so I'm not even going to mess with them anymore. I'm not. I'm not going to try to organize. I mean, that was too much energy anyway. We should probably put a Pomo timer on though. Z Pomo start. Let's start that so we give everybody a break at some point. Oh, my TMUX is not on right now. All right, so let's turn TMUX on. TMUX. We talked about TMUX already, but I don't know how familiar you are. If you guys are using it, we talked about the commands for TMUX, so I don't know, how much of this you guys are doing or whatever. All right, so yes, // good job. Jimmy, thank you. Thank you for the right answer there. So dir, max step after the argument of the global option. So that's something wrong with my find command. So I obviously copied the wrong one. So how did I do that wrong? Did I do it wrong? Let's try again. There we go. Max step 3. I mean, that's fine. Let's do -t type D. Oh. So that's all the directories only, right? To the max step to 3. Why don't I have a shebang line in here? And why is it working? This is all review. If you don't, we covered this last week. I'm just going to ask for as a review. Why is it running? My friends, why is this running? How is it able to run without a shebang line? You guys remember what a shebang line is? What does sh stand for and bang? Default interpreter is bash. Yes. So this is bad form. It will work, but it's bad. Because why? Because if you share this script with somebody else, thanks for the fall. If you share this script with somebody else, what's going to happen? They're going to put it on their Z shell Mac, and they're going to try to run it, and they're going to be right. What will happen? You want me to show you? I'll show you exactly what will happen. It'll be the same as if you set the shebang line as Z shell. Yeah. User, don't do this, but bin env. Actually, it will work. In this case, it would work. In this case, it would work because it's the same. Oh, there's no Z shell. Whoopsie. I mean, it would work. It would. In this case, it would work. Did I delete it? Shit. I mean, something besides that. I'm not supposed to swear on the boost. Anyway, we don't want user bin env bash. Why not? Why would you do this? And why? You're going to see this all the time. Okay, I've talked about this a million times. I've talked about this so many times, but I want to review this because this is super important. I get this question all the time. What's better? Which one should I use? All right, so these are all places you're going to find bash, right? These are all full paths to the bash program. Okay, I'm going to ask a question. I talked about this already, but I really, really, really want to punch this home. We talked about path. Remember path? What is path? What is path? You don't have one of these yet. I'm going to help you make one. So that is my path command. Type path. Here's my path command. So here's a nice, easy one. We'll make this one later. We're going to do this when we do parameter expansion. We'll talk about this. This is really, really good for parameter expansion. So this is my command that shows me everything in my path. And yes, I use user bin env. Why? Because it's relatively innocuous, which means no one's going to die if they run it and somebody messes with the path. But what happens? So I just want everybody to be clear on this. I've talked about this so many times, but I'm going to continue to harp on it. When you use user bin env, it finds the first binary named bash, B-A-S-H, in the path. And you can totally own a system based on that if their path is misconfigured. So the more secure answer to this, if you're like doing enterprise, and I do, if you're doing enterprise, if you're doing like little scripts for yourself and you just want them to work on your Mac or your friend's computer, or you really don't care, user bin env bash is fine. But the Ruby people primarily have really pushed this usage into the enterprise, which I find very disturbing, because what it does is it completely discounts the ability to own. It opens up a security vulnerability for permissions escalation. And I just cannot overstate my disagreement with this. In fact, in the old days, not only would we use bin bash, but in order to make sure that none of our commands were ever owned. So I'm calling find here. How is it even finding find? This is a security thing. This is more suitable for the offensive security channel, but I still want you to know this so you can own people. Back in the day, when you wanted to write a secure shell script, you used full paths, fully qualified paths for everything. And we stopped doing that for laziness, but it was actually much more secure. So this is more secure than this. Okay. Why is that more secure? I'm giving you a chance to think about this, and I'm going to answer. The reason this is more secure is because it does not use the path environment variable at all. Right? As you can see, user bin is one of the directories here in our path. But as you can also see, look at all of the directories in front of it. So here we go, user home, local bin, right? So if there is a program that executes, it could be Perl shell, whatever. If there is a program that executes that has the name find, right? If it is found, look user bin games. I even put user bin games here. This is not a very secure path, right? It's on my own VM, but this is not very secure. What if I sudo apt install something from Arch? This is why the AUR in Arch is the devil when it comes to security. Arch might be a fine operating system, but when it comes to the AUR, this kind of stuff allows people to pwn noobs all the time. And I don't want you to be pwned, my friend. I don't want you to be pwned, and I'm going to tell you how. So let's say I'm going to give you a very real hypothetical, very real hypothetical. I'm going to give you a very real use case here. So you are setting up, this is about, we have to understand paths and environment variables. I'm in the middle of a really intense, I'll take a break in a bit. So thank you, Doris. I gotta chase out of the room. She's bringing me pancakes. So let's say you're an Arch user, okay? And you do not know how dangerous the AUR is. You're just using it because some dweeb told you to use it without asking you what your skill level was. All right. And that happens all the time, and it really bothers me. And so you install Manjaro or some crap, and you go in there and you're like, and like, wow, I want to install these games or something or whatever. And so you put user games or something like that ahead of user bin and user sbin and stuff like that. All this stuff down the bottom, which is generally considered secure, right? Even snap bin is ahead of this. Oh my God. So then what? So I want to own you. So I go out into the AUR, which is completely anonymous, by the way. The AUR is completely anonymous. There's no way to track people down in there. I mean, there is, but you go in there and you say, okay, I'm going to make a game. So I'm going to make a game called Find, right? But my game, or I'm not, my game is going to have something. Actually, maybe you want to put a game in there, and then you also want to include like an extra executable so you can own them. So you want to put a Trojan in there, right? So then you include in your game a command called find, or I don't know, ls, right? You include a command called ls, maybe even a command called cd or something. And I think cd is a built-in, thank God. But by the way, another reason to use bash as your interactive shell and not POSIX or something. You can't use POSIX, nobody does. But anyway, so you install this thing, and now all of a sudden, when you run find, as long as it still provides the same out, or ls or whatever, as long as it provides the same output, you don't even know you've been pwned. And every time you run that program, you're running it with your permissions, right? So it can do whatever. It could say, hey, I'm going to go write this, because you might have, so this is a way to hack people. But how is it defeated? By providing the full path. I'm not saying to do this unless it's inconvenient. With security, there's always a level of convenience versus, safety. And in this case, nobody wants to type user bin find. Back in the old days, we used to do this. We used to say, we would do something like this: find equals user bin find, right? And we would force people for every command used in the script to be assigned. Because by doing that, you're locked down. If any one of these commands is in the wrong place, the only way to own somebody with a script like this is to actually Trojan the command itself, which is being done these days. I just read a whole bunch of stuff about that. Some of the core commands are getting Trojaned. Another way to get around that is to control the path. So to control the path, and you see this all the time. So you would say path equals, right? And you would say user. You could do this. You have to be careful with this because you can really lock your system down. Cron jobs do this, by the way, and it gets really annoying because they don't see things you think that they could see because they're running as root. So sometimes, user bin. So we know it's there. We want user bin. We want /bin, right? And so in the old days, you won't see this. It's really too bad because we're getting owned all over the place. And if common security measures like this were followed in enterprise, we would be fine. Yeah, just stuff like find equals which find in your scripts. It's totally stupid. Unless you're trying to look up the path. If you truly want the path and you want to examine the path, Minerva, then that makes sense. Otherwise, why are you doing it? Just use it because it's going to resolve anyway, right? I think that's more important. By the way, if you're going to do which, use command instead. So I'm going to give you a hint here. So use command instead of, this is something I learned very recently. Command is actually safer, and it will actually give you, it's better than which. So why is command better than which? For scripts, right? So I'm gonna let you. I'm talking too much today. So we're gonna do this. I'm just gonna put that as an exercise for you to figure out. Use command -v instead of which in scripts. I just put that in there really quick. All right, so, and you'll see the difference. It's more reliable. It gives you a full path. If it doesn't, it returns true or false properly, which will return a false positive. Yeah, it's weird. It's very subtle, but only people that know what's up with programming know that. So let's go back to that. I'm almost positive it's command -v. Command -v find. Yeah, that's the one. I only learned that like 2 years ago when I first started streaming. Actually, somebody mentioned it. It's really important. All right, so what are we doing? We're doing a script, and I was going off on security. Will this run? I don't know. Let's see. Sure, 3. Warning: you specified a global option maxed up. Did I not change it? I thought I changed it already. Type equals D. Type D. Yep, it did. All right. I sometimes do stuff like, yeah, okay, same thing. So anyway, this is, you see it still runs and everything, right? But now what? Now what? I can't own myself, right? So let me show you how I could be owned. So let's go into user games. All right. Ooh, look at that, right? And watch. I'm going to sudo. And this would happen. It's the same. Basically, I'm simulating an install. So if you'd installed something that put in locap, but maybe some extra thing, right? So we'll say find. Permission denied. Sudo touch find. Tough. All right. Schmucks find sudo. God damn it. I should have just done it right in the first place. All right. So sudo vi find. Bin sh echo wahaha. Cow say to echo. I'm gonna put in a free path. Yeah, you know what? That's nice, but this is all you need. It's a one-line echo command. You made a GitHub repo and everything. It's kind of cute. I'm sorry. Okay. Anyway, I mean, we all have done it. I did it. I mean, I would have done the same thing on a 20-line Perl script back in the day. So, here. So watch. Now my let's run. First of all, let's run find. Uh-oh. My find command has been taken over. Which find? Command-v find. Uh-oh. What happens when I run my dir program now? Oh, still works. Why? Why does my dir program still work? Why does it still work? I'm going to edit this. Make sure you grok env and path dangers. I specified the find. Right. Okay. So there's two ways to fix this. I said, look, there's no other find in there. By the way, check this out. Command. So let's use Minerva's thing. Okay. So I could do this, right? Find equals, I don't know why you would, but you could. Command-v find. Right? And now we could just use a $find. We probably should do this though, right? To be safety. If we don't do that, by the way, what's shell check going to do? Let's do it. Shell check dir 3. Oh boy. It's okay with it because I thought for sure it was going to yell at me. This is probably safer. Anyway, so echo find. Now it'll yell at me because I didn't do a thing to it. Yeah. See, I didn't, because it was a command line argument. That's why. All right. So my script is nice and safe. Let's run it. We talked about shell check already. I'm not talking about it again. If you're not using shell check, you need to. Okay. Look at that. User bin find. But Mr. Rob, find is under user bin games. No, it's not. Not in the shell script. This little thing that I'm freaking out on and I'm spending a whole 30 minutes on is not covered on the internet anywhere. If you find any places it's covered on the internet, I'll give you like 1,000 rep or something. Because I have never been able to see, in my random casual strolling around and YouTube and stuff, nobody talks about this. And the internet is plagued with crappy scripts that are running as set-ready root sometimes that do not take into account the path. And guess what? If you're a hacker, you love that. Because if you're a hacker, all you have to do is write a nice little script that just searches for GitHub and it looks for all this stuff that doesn't set the path that uses user bin and env. And I promise you, you'll find an app that you can escalate and own just by doing that search. You didn't learn it here. If you want to hack somebody, just write your own spider on GitHub. Write your own spider on GitHub and look for all that crap. Because even the GitHub security stuff is not looking for that because they're writing it. Did you already find it? Of course you did. It's so, look, so again, learn like a hacker, think like a hacker, even if you're just an ops guy or girl or they person. And you'll so we've learned about a lot of, we've actually learned a lot of basic stuff in Alias. Yeah. All right. So we've learned a lot of things here that are not conventional. So we talked about the difference between command and which. So let me just review everything that's in the script so that you understand. This is we're jumping right into writing useful code, which means that we're kind of bouncing around in bash syntax. Okay, so why did I have export here? So we talked about variables. Let's deconstruct this particular script, and then we'll talk about what it does. So first of all, it's using bin bash because I know it's going to be running on my system. It's not going to be bouncing around to my Mac and back. I don't normally do that though. In my own scripts, like my path, like I just showed you, in my own scripts, I too, actually I'm replacing all my scripts with a Go monolith because I don't want to have to deal with the security implications, and I just want to copy one file. And we're going to talk about that. We're going to write a bonsai Go monolith that's going to replace all my shell code. We're going to probably start doing that in a couple of weeks. We still need to do configuration of bash, tmux, and vim, which maybe we'll do next week. And then after that, we're going to be all about Go. So we're probably going to be coding Go until Christmas, the way things are going. So, but when we code Go, we're going to code Go bonsai utility monoliths, which is the thing I invented to take the danger and the problem of having a bunch of bash scripts and put it all into a single executable, which seems non-Unixy for a bit, and we'll talk about it later. But the point of it is you don't even have to deal with these path issues anymore because they're all gone, right? And we can do the equivalent using that, and then you can share that utility with anybody, and they can just import it into their own code if you want. Okay, so but we got to talk through bash in order to get there. That's why I have user bin env here, is because who cares, this can't be owned. They'd have to echo as a built-in. There's really nothing to own here. So be able to use this, but why isn't it an alias? Why isn't this an alias? Let's talk about that for a second. I'm gonna leave this one for a bit. Why is my we talked about that earlier. I'm gonna come back to it. I'm gonna put that in my tips. Grok diff pros and cons of aliases, functions, and commands. All right, we talked about this already, but I'm going to do it again. So we're going to do programmable. We're going to do parameter expansion. That's what this is later. Okay, all this does is replace any colons with line return. That's all it does. It's pretty basic, but it's very, very powerful. And but why is that a command, right? I'm gonna tell you why. Okay, so let's say I'm editing a Z, right? I'm saying, I don't know, Z create dangers of path. Okay, and I'm writing a Zettelcast, and this is my own command, and everything. We'll learn how to make this. And I'm like, sometimes here is a typical path, right? We learned Markdown already, so, okay. And so I'm going to actually write the command. I'm going to use the bang bang command. I'm going to use bang bang to replace it. And now I can do this. Watch. I can write path. Bang bang bash. Boom. Do I need to do that again? Rewind that. If you didn't watch what happened, go rewind it and watch the video again. What I do, I wrote a path and I went bang, bang, bash. I sent my command, because it's a filter, and it replaces the current line with the output of the command. If you're not doing that and you don't understand it, go back and watch Vim filters, which is like 2 weeks ago, I think. And now I can mess with this. I'm like, okay, well, and then I can, boom, I got my sample, right? See how fast that was? I didn't even have to really do anything. Show an alias since it will likely never use the Unix filter. No, it never would be. No, and here's another reason. Actually, so let's do this. What if I have? But let's try path as an alias. All right. So now before I get into this, there's always some pedantic person who comes at me and says, you can make that happen. You just have to change your settings to your bash environment. I'm like, okay, fine. I mean, maybe I could be convinced. At one point, to be fair, every single thing I had was in an exported function. And we haven't covered functions yet. We will. So let's do that right now. Actually, if I wanted to put all of this into a function, how would I do it? Now, by the way, I'm not telling you to put export path or any of that stuff in there unless you don't want to. I'm just leaving it here to remind you when security is paramount. Okay. So we're gonna do that. All right. And we don't have to do any of that. We can just do find here. I'm gonna take that back. We'll leave these as kind of debugging. Remove me just for debugging. Oh, I'm going to leave this code in here because I know people want to refer to it later. So we have her maxed up, and I had to look that up like every day. And what? Okay, so let's say I want to reuse that. Let's say I don't want it to just be a one-liner. Now I make a lot of one-liner scripts. I call them utility commands. Or no, what is it? Command. I can't remember what I had a fancy name for them because they're really the same thing as an alias. I mean, you can make an alias for it. So let's do that. Okay, let's do that. Which path? All right. So let's go kill path. Oh, I should probably remove find. It's gonna screw me up later. I'm gonna like rename something important to Muhaha. So we got. Oh boy. Sudo rm find. Got to be careful with that. Hey, thanks for the sub. And all right, so then we're gonna go. I mean, we're not nice and clean here. Which path, right? So I want to use this path thing, yeah. But we're gonna screw it up. Scripts, CD scripts. You see that? You see how far I traveled in that CD? That's because of CD path, and we will talk about that. A lot of people don't know about it. And so what? We're gonna come over here. We're now in the scripts directory. I got all my stuff in here, yeah. And I'm gonna move path. I'm gonna move it to old path. All right, so now when I do path, what I get? Oh, no such thing. Right? All right, so let's go back to our thing here. If I try to do this and run to bash, command not found. Right? Okay, so let's pretend like it wasn't a command at first. Let's pretend like the path command was an alias. All right, so to do that, I have to close this out. It's going to commit this to GitHub and everything. But we're going to go ahead and write it. We're going to write, I don't know how much time we're going to get. So we're going to go ahead and make an alias. All right. In fact, I'm going to do the alias. You could just do it from the command line here as long as this terminal is the one you use all the time. And then we're going to show you how to get into bash config. Okay. So an alias, we can say alias path equals, well, I'm lazy. So give me a second. I'm cutting and pasting using tmux. All right, so we're gonna do alias path equals quotes paste and another single quote. Right? Why do I need the single quotes? If I don't do the single quotes, then these things will resolve. So whenever you're defining an alias, whenever you're defining an alias, you need to make sure to do them in single quotes. Because if you don't, anything inside of here will be resolved when you're defining the alias and not when it runs. So then I can type alias to see if it worked. Type path and see if it worked. And you can do command-v path, and it will tell you exactly what it is. Okay. And so let's go ahead and try that now. So if I run path, what do I get? Oh, hey, it works. Until it doesn't. Oh, thanks for the sub, Humble. It works until it doesn't. So let's go edit that last Zet I was just editing. I'm going to go edit my last Zettelcast. So here's this path, remember? And I did bang, bang, bash. So I'm going to send path to the bash command line. Uh-oh. Path not found. You can't use a double quote. Why not? You want to try it? Let's try it. Let's see what happens if I use a double quote instead. Yeah, if this works on your machine, then that means you have configured. Oh wow, thanks for the hype train. Thank you. So if this works on your machine, then it means one thing. That means that you have configured aliases to behave like commands. All right. So, and that normally that's a pain. Normally that's a pain in the butt. You don't want to do that. Let me give you another example. Let's say I want to get the current Pomo script time right now. Bang, bang, bash. It gets me the time. So again, it's replacing the line with the output of the command. And the zpomo command is what's generating this stuff up in the corner. Okay, so I can do that. It's the same idea. It's also why I'm a big fan of monoliths these days. This is why aliases are not that good. Okay, and this is why I actually have written extensively about this. If you want to see more about it, you can do ZQ alias, and that will show you all my ZQ. That'll search GitHub for all my references to aliases. That was actually quite. And you know what is even worse is it also doesn't functions. I'm not going to go into this because only people that know how to code will get it. But exported functions in Bash would work in this case. But to the advanced people out there, when would an exported shell function not work? Anytime you're going to do an exec syscall, which means it works fine from VI, which has a parent shell of Bash. But if you are writing a binary, if you're writing a Go program or something like that, and you're using the sysexec call on the thing against the binary, it doesn't have a shell to expand to get the function. So the function is useless to you if you want to execute something from the shell. And this goes back to the same argument I made about making your executables, I call them executables because it's literally anything that will execute, not have specific things that can change, because you might want to rewrite a Go program. So let's say you write a monolith, right? And it wants to do the same thing. You write a Go program that does the same thing. When it goes to run your exported function or your alias, it won't work. We already know why the alias won't work, right? Because it doesn't get exported through the subshells. Functions do, however, if you do export-f on the function, and we'll get to that, that will actually export the functions. And I did this for a full year. And then I wrote a utility or two that I wanted to call from my other Go utility, because I want ubiquity. I want to be able to plug and play my utilities. I want it to be in C. I want this one to be in Go or whatever. So I upgraded one into Go as a compiled binary. And I tried to call one of my utilities, like path here, as an exported function. Guess what? It didn't work. Because it has no idea. The Go executable has no idea about Bash. Which is why it's so awesome, because then you put it on Windows, it works until it doesn't, right? So the only way to get around that is to make one-liner executable commands, or to bundle all those together and put them in a monolith, which is what I'm doing right now. If you want to watch me do that during this winter when the weather gets bad, I'm going to be making my own monolith out of I'm converting all my Bash scripts, which I got hundreds of them. I'm going to convert them all into single commands in Go, and then I have one command at monolith that'll run a Windows, Mac, or anywhere, and then I don't even care what my shell is, because all my filters are now bundled into my Go monolith. This is why Go is the preferred language by hackers right now, by far, for malware and all kinds of stuff, because it's just so amazing. Anyway, so back to where we were. We're going to learn some Bash, yeah? I love Bash too, but I just wanted you guys to see that. All right, so Zet, delete last. I just need to delete that last one. I don't want to have that like a mess in there. And Zet, by the way, is going to be ported. My Zet command, I'm going to port that to Go as well. 94% hype train. We're so close. Okay, so let's go to... So we've talked about that. Rock pros and cons, aliases, functions, and commands. Review this and just know it as a tip. Make sure you understand the difference. I promise you, you will work with senior people who have been in the industry for 20 years who cannot tell you the difference between an alias, a function, and a command. They can't tell you. They've been doing it forever, and they have no idea about the difference. And the difference for not being able to export functions, but you can't even export a function in Z shell. I mean, you can, but it's complicated. Oh, look at that. That was nice. We hit it. Woot. Hey, Tiberium, thank you. Thank you so much for that. I actually haven't had a hype train in a while, so it makes me feel good. With just 65 people, no less. All right. So, but the reason I'm telling you all of these rabby holy, like little tips is because they are not covered anywhere else. Okay. So that's why. I mean, even security people won't tell you about that stuff, unfortunately. It's kind of sad. So anyway, so here we have this command that we wrote. So let's talk about the path really quick. I'm going to do some review. We have 18 minutes left on this Pomo, and we'll take a break. Go drink or get a drink or coffee or whatever. So path. How do we define a variable? A variable is just something equals something. There cannot be spaces around it. We talked about that already. If you know that there's nothing fancy in the path, you don't need to put quotes around it. Somebody asked, what's the difference between double and single quotes in the alias? So let's talk about that for a second. Okay. So right now, if we do the type on, was it path? Oh, there's the path. So alias, right? Alias path equals, and I used a single quote for this variable assignment, or this, something equals something. And let's paste that. And I use single quotes. Now we're going to talk about type path, right? Okay, now watch this. Let's use double quotes. I'm trying to use specific examples so you can see the difference rather than just tell you the difference. All right, so if I put double quotes, anybody want to guess what's going to happen? What's going to happen with the double quotes? What's going to happen with those double quotes? Expands, right? What specifically is going to expand? Something's going to expand, right? All right, so let's type it out. Path. What the hell? Look at that. So this is my alias now. Maybe there's some case where you actually want that every time. If I type path, what will happen? Oh, that's not kind of what I wanted. We're going to bash. So how can we make aliases present in bash RC work in Vim? You put them in a single executable script in a path in a directory. That's what I do. That's how I do it. Hi, Ridril. Welcome. Yep, I just played myself. So we're going to do that now. This is the reason I'm showing you this, because the next thing we're going to do is we're going to start configuring. By the end of today, we'll be successful if you know where to put your little utilities and whether to make it an alias, a function, or a script, and you know where to put stuff. That is the goal for today. Okay, and some of the syntax of bash, which we've already covered. Okay, so the most basic thing in bash that you'll do, besides executing just any command, is defining a variable, right? So by default, a variable is just path equals sum, right? And all the stuff you can do from the command line, you don't have to put it in a script because interactive bash. So what happens if I type path now? Uh-oh. Why is it doing that? I made it into a variable. I'm confused. Oh, it's squashing it, okay? By the way, if you want to get rid of your alias, you type /path and it'll look for a path. It's like, I can't find it. Let me give you an example of that. So this is super important. All right. So I'm going to put this in the tips actually, so I don't forget. I've said it before, but use precede anything with /. I can't even have a / to disable aliases functions. All right. So let me show you an example of this. This is super important. We'll put readme here. All right. So top. So top is this cool bash top version of top that I found that, it's kind of hard to read, but looks cool. And it's slow and stuff. And sometimes I just want the regular bash, right? Well, so let's go see this. So type top or command-v top, same thing. Which top, right? So we see that this is, by the way, is why you should use command-v. I don't know who was asking before, but this is why. In fact, check this. Type top echo $. This is return value, right? Oh, look at that. Hype train. I got a hype train emote. Yay. All right. So let's do which top 0, right? Let's do command-v top. So all of those are 0. That means they're all true, right? So thank you so much for that. So we've got a lot of weirdness going on here because, like, if you're trying to tell what kind of thing you have, they all give you the thing, So what this is telling you is there is a top command, but when you run top, it's not what you think. Right? So how do you make sure to run the right one? Which one am I running, by the way? When I type the word top, enter, what happens? What gets executed? Does it run this, my alias, or does it run this? I mean, it's pretty obvious, but it's been running bash top, right? I don't want it to do that. I want it to run this one. It's running bash top, right? But if I do which top, I mean, if you only know about which, this is why command-v top is so much more important. I use which all the time because of habit. I use which all the time because of habit, my friends. But in this case, it's wrong. So many beginners will come to this and they'll go, "Oh, I want to see what top is. Oh, which top?" I'm like, "Oh, it's user bin top. Okay, cool. So user bin top -h or something." Oh, okay. Well, that doesn't look like what I'm running. So what I want to tell everybody here is that, and I learned this last year, is that if you are scripting this stuff and you want to see the truth, you want to see the truth of what a thing is, the fastest way to get the truth is type. The problem with type is that you don't get any output you can really parse and use. This is what I'm trying to tell you right now, Patricles. If you use command-v, you will get the exact code of what the type thing is, right? Top is, I mean, people use backticks all the time to get a full path, right? If you use which, you'll always get the path to this. But if you need to detect if it's actually if it on the system, if it's a function or an alias or something, you need to use that. So command-v, and you can read about this. Command will tell you that that's print a description of command similar to the type built-in. This is the standard way to do this. And if you look at some of the better shell scripts out there, rather than grabbing which thing, they'll always grab command-v. So this is more for our veterans. Please make sure you understand the difference between that, because it is really critical. And I put that in here. Okay. It is critical because you'll be on a system that has an alias or function or something like that, and you will not get what you want. And it's it's an edge case, but still, I wanted to just make the point of like, it is there, it's a thing. So where are we? All right. Wait, what? Oh boy. I really screwed up because I'm going too fast. All right. So, yeah, I don't use control and expand. That's dumb. Don't do that. If you want to do that, that's fine. If you want to use Emacs mode, but you don't. So, yeah, I don't do that. That's not supported everywhere. I wish it was. But I don't use control commands at all because they're all Emacs mode. What's the output if you run command-v on a command that is not aliased? Try it. So command-v ls. Oops. Command-v find. There you go. Which find. Type find. Find is user bin find. Oh, this is why. I used to use type because I wanted to get this thing here, right? Yeah. And they have different return codes, by the way. So you can look into that. I don't want to get deep in the woods on that one right now because we got beginners watching. But the main point of all of this is top. So I run top and I get bash top, yeah? Which top? Okay, user bin top. What the hell? Someone tell me what just happened. I thought I ran the right ones. What happened? What's the difference between top and user bin top? Top is running bash top. I'm trying to find a VI mode equivalent. Yeah, please do, Mousy. We haven't done VI mode yet, but we're going to talk about it when we get in our config. We might have to do bash config this week. I don't want to. All right, so what I'm trying to say is this. Top, type, top. So type, if you're doing interactive stuff, the type command will always tell you what it is. And if you're new, if you're brand new to this, you may be told, yes, /top. And you may be told to use which to find out what command you're running, right? And that would be wrong in this case, right? Because which always tells you. The reason it's which thing is in your path, right? Which thing is in your path. If it's not in your path, whoops, I killed my old path. There we go. So if it's not in your path, which will return nothing. It will be false. So if you want to run the one that does not have an alias, this is something I learned 2 years ago in Twitch. Type /top, /top, and that will disable any aliases or functions that are already defined in bash. And it will use the one that is returned by which or command-v. And that will give you the one you want. And a lot of times you're going to need that. You're going to need that because you're going to be on a system where somebody else has alias something. You know, somebody's done something silly with ls all the time, right? I mean, somebody's done like really silly things with ls, and it's the kind of thing that people will do. And you'll be sharing a terminal, you'll be on somebody else's terminal, and you're helping them or something. And you know, you just need to use the actual ls command, right? Because that's not ls. When I do ls, I get color, right? So ls here, I get color, but I don't want color, right? Or whatever, right? There's just a million reasons that you might want to disable aliases and functions, and that's how you do it, is with a /. Okay, I spent a lot of time on that. All right, so let's go back to scripting. Let's do the basics of the syntax. How much time we got? 6 minutes. Okay. So actually, no, let's wrap up. Is there any questions about anything we covered so far? We hit the path stuff. We hit making a directory pretty hard. We reviewed making a script and putting something in the script to run. I tell you what, with 6 minutes left, let's go ahead and introduce functions to you. Okay. And people think I'm crazy for introducing functions first. I think variables are the most important thing, and we did that. This is a variable. One last thing on variables. When you put export in front of the variable definition, then all the programs that run, that this program might start, all the programs that this program might start also get that variable. Let me say that again. When you export a variable in bash, any programs underneath this program that get started, and you'll remember the whole PS tree thing, right? You can install PS tree and see how programs work, right? You have one program, it's a parent, and it runs another program. So here's my tmux, and then I have a bash vim running, and I have blank pane that's over here. My pomo's under there. This is pomo's sleeping, and there's no PS tree. So when you consider all those processes and their little kind of, you know, ancestry or whatever you want to call it, pedigree, then when you run a program, at least when you run a bash shell script, the variable that you've defined is not exported. In fact, you can do this just fine. The only reason I exported it is because I wanted to protect any of the programs that are being called by this program. If I do this, it only protects this program. It's not as intrusive, right? If I put an export here, there's a good chance some program dependency I have. So maybe I'm going to call another script, right? And that script is not as picky about where to put stuff, and it will fail. So this is the most secure way to do it. I mean, it could be either this or the other one. If you just wanted to affect only the things in this script, then you don't need export. That's going to come in later when we do configuration. When we start configuring things in our shell scripts, and we want environment variables to live, you know, an environment variable, by the way, if you want to see all of your variables, that's what env's normal usage is, right? And mine's really ugly right now because I have a bunch of exported functions and colors in there and stuff. In fact, let me fix some things here. So let's do, let me put my README here. Say use env to see environment. Environment variables are variables. We talked about this already, but environment variables are variables that live in your environment, your entire script, everything that's running, including executables, they can all see. It's a good way of communicating between things. In fact, in the old days of Common Gateway Interface, CGI scripts in the web, this is a front end thing. Back in the 80s and 90s, when we wrote CGI scripts, the way that the query string, the key equals value, question mark, key equals value, question mark, key equals value, whatever, ampersand, key equals value, whatever, those things were actually put into an environment variable in the script called the query string, and then you would parse it apart. So environment variables are used to pass data between applications that are running, okay? And you'll set an environment variable, other than command line. Yeah. Okay, cool. Thank you for that. Is it a Stack Exchange, really? I'm not linking to Stack Exchange. Sorry. And buying shell expand line. No, not doing that. No. Okay, so to defer your path in every shell script? No. It's only good practice if you have a really, really high security requirement. If you're writing enterprise software that's going to be running a lot of different places and it needs to be really locked down so that nobody can mess with it because it's going to be running. I mean, first of all, you can't run it as root unless you have a set UID wrapper, which is really, really, really dangerous. So the answer to that is no. You should not. The reason I'm saying this is because what you'll end up doing is you'll end up sharing that same script with somebody else who has stuff in a different path, who's organized things differently, and it'll break them. It'll break them. They'll have to go put their stuff in the right place where you expected it to be. So, but the reason I became so pedantic about that whole thing is I just want you to understand the scale of security considerations when you're writing a shell script, because nobody talks about that. They talk about making shell scripts convenient to run anywhere, and then people curl them off the internet. They don't even look at them, and they run user bin env, whatever, and then they just, after they've installed 5 Arch things, that they don't even know where they came from. And that's kind of our mentality right now in the industry, and that's killing us because we're getting owned all over the place. And then on the other hand, you have, forcing every single thing you put in a shell script to be a fully qualified path that'll only work on one system, right? Because some other system might have it in a different location. For example, Mac Z shell stuff puts everything in user local bin, which is totally retarded, but whatever. And then you have, stuff that's in other places. But so the more secure the script has to be, now you know the scale and the scope of security you can add to your script. So if you are writing, and you'll see this, by the way, if you look in some of the Debian system startup scripts, I'd be hard pressed to find one right now. You'll see that these are scripts that are running at boot time as root, and you'll start to see these considerations. For example, in the cron jobs, right? People get pissed off all the time because cron jobs are way locked down. The path, if you write a cron job, we don't do cron yet, but if you did a cron job and you echo the path in cron job, you'll see you only get like 3 things in your path. And by the way, even if you export the path, doesn't matter because it gets overwritten every time because so many people have owned systems through cron that they are concerned with that. So I don't want you to be hyper paranoid, especially if you're just writing a utility script. Like you saw, I use user bin env bash for my path because I'm not doing anything secure there, and I want to be able to. It's more important that I be able to share it. Yeah, there's always a trade-off, and so that's what I'm trying to say. I don't want anybody to walk away and talking a lot about this because I want anybody walking away and say, "Oh, you didn't export your path. You didn't force an explicit path. You're a bad person." That's not the case. It depends. It depends. And like so many things in life, you have to look at the situation. If you're writing an enterprise startup script for a major application that's going to run in 30 pods in Kubernetes in a massive deployment in an investment bank, then yeah, you might want to think about that. I mean, one of the reasons that containers exist is to mitigate this problem because containers are already, they lock everything down. And I would actually go so far as to say that the reason containers are so popular is because there's been so much crappy code written over the years that writing a monolith safely is no longer a consideration. No, we're going to break it up into 10 microservices, and we're going to have all those things be their own containers because we want them to have everything locked down. Okay, so it's just extra. That's not what I'm saying. So there. All right, so if you want to see all of your environment variables in your system, you can run env and pipe that to more or something. It's probably bad Sometimes people will put passwords in their environment, and I haven't. I swear. By the way, some people seriously, if you if you read documentation or a Stack Exchange that says put your database password in your environment variables, you need to find the person that wrote that and strongly berate them because it's so stupid. You can anybody on the system can see all of your environment variables. Has anybody out there with experience ever actually seen this? I've seen this so many times I've lost count. And people say, well, it's not a multi-user system. Are you sure? Such bad practice. People do this crap all the time. And if I have to, global variables. Jalape's in here trying to troll us during our learning session. So basically, here's all your environment variables. These are variables that anything on the system can use. Okay, these are variables anywhere on the system can use. Put them in an env file and use a wallet service event. Yeah, and that's what most people will do if you're using containers, right? But yeah, it shows you where your connections are. These are all things you can look up, right? And you can export them. So these are, again, environment variables are just variables that are exported that are usable by everything underneath it, including other non-bash things. And by convention, they're all uppercase. And that's been a thing since the dawn of time. All uppercase is the convention in bash that is used for both environment variables and global variables. And there's a very small percentage of people that will tell you that all variables should be uppercase in shell because they're all global. And that's not true because bash has localized variables, but they don't. So there's some old farts out there that will tell you that, and they're wrong. Bash doesn't work that way. So it does by default, but if you're doing this right. So let's how much minute time we got? Oh God, we're 3 minutes over. We're going to take a break and we're going to come back and we're going to continue the variable definition, and we're going to move into functions. And the reason I want to move into functions is because that's going to introduce the idea of scope. And we haven't talked about program scope yet, or namespace scope, or any of that. And thank God Bash has it. POSIX does not. Okay. If not, then when you use supply them, the programs required that way. If you're not passing them as environment variables, I mean, there's lots of different ways. People will write them out to a file and make sure it's got. They'll open the program and send them a standard input. That's the safest way. Yeah. Those are kind of leading with scrolling through man pages. Mine? It might, yeah. It depends. There might be a little bit. I might have some wrong settings in there somewhere. Yeah, it does happen on occasion. All right, we're going to take a break. Let's go. We'll put the fishies up. So now's the time to ask your questions with him. I'm going to go ahead and take, let's take 10 minutes, 8 minutes. How about that? Term down. So 8 minutes, 8-minute break. Breaks are for you to ask questions and, take care of biology and that kind of thing. So break. Again, if anybody has questions, this is the time to hit us with them. I mean, if you want to catch up or something like that. So I am going to go possibly get more coffee. I don't know. I'll be back. You guys want music? Should we do Linkin Park? I'm making that decision for you. We are doing Linkin Park. I don't need to worry. This loud Linkin Park's never making it in the VOD. Because I'm using Twitch's super fancy channel 2. If you haven't learned about that, I strongly encourage it. Are you singing? Are you singing? Are you singing? Oh, I can never get enough of that, huh? I can never get enough of that. All right, what are we doing? We were learning how not to get owned and how to own other people. Suggest a poll. How much of his experience? How many people coding, if at all? How much years of experience people have in coding? That's a great poll suggestion. Let's talk about that on the next break, Ridgewell. Will you remind me? That's a great conversation starter, but we just finished a break. So next break, we'll stay here and we'll talk about that. All right. I think it's important that that everybody know that I am not primarily a software engineer. I don't like the term developer. I'm an ops person and a hacker who happens to know how to code relatively well. Written my own languages and stuff. But it's like it's relative, right? There's coding in everything. So yeah. So let's go ahead and change this. So let's go back to variables. So we were talking about how to export variables, how to make them, what they're for, and I promised you that we were going to talk about. Let's actually set our POMO. Let's set a new POMO Z POMO start, and we'll go for another 51 minutes, and we'll take another break. All right, so let's take our little command here. Now I know you don't really need it right now, right? But what if we wanted to make it into a function, right? So rather than right now, it is a command. The command is called dir3, and this is actually something I commonly do. This is a convention I regularly use when I am not sure if I might want to take that bit of code that I wrote, and I might want to combine it into another bash script that has all the stuff in it without having it be strewn about in separate commands. And it's important. I mean, when we talk about the Unix philosophy, it's like doing one thing well, one script well, right? But you can apply this same concept within the same program by breaking the code up into subroutines, procedures, functions, whatever you call them. I call them subroutines for this. Just basically mini little scripts inside of the script that you can call. And that's the way to think of it. And when we get into more formal development, we talked about the difference between procedures and functions last week, kind of ad nauseum, but it's time for us to go forward. We got a question, or I missed something. Sorry in advance. Question. No. All right. So we're going to go ahead and we're going to do a function here, right? So let's make a function that's the same name as the program, right? And we did this very briefly last week. So, and then I can just do dir3. So it's kind of like I wrote all the code for that function and I put it in here. And what makes it a function? So the syntax, what does syntax mean? Right? What does syntax mean? We talked about how to terminal search like three boosts ago. So if you don't know how to do that, practice that. Syntax, the way in which linguistics elements such as words are put together to form constituents such as phrases and clauses. The part of grammar dealing with this. So syntax is how we write things. What are the rules? How do things go together and all that? And every language has a syntax, whether it's English or Bash. And, you know, some people would say those who excel with foreign languages, you know, natural languages also, you know, excel with programming languages. I believe that's true to an extent. I speak French and Russian as well as English, but I don't believe it fully transfers over. I think it's more about mathematics and functions, and we covered that extensively last week. If you have linear algebra under your belt, you should be really good with code, because this subroutine is kind of like a function. And it really isn't though, right? In this case, it's not a function because there's nothing coming out of it. And that's something I really, really, really want to emphasize with Bash. All right. There's really, the return codes from Bash are much, much different than other things. And we talked about that last week. I will recap it a little bit here. So I can run the same program now. Here I can run dir3. And then we have to, I don't know where you're writing all of this. It could be just in your home directory. I promise we'll get back to organizing everything like I started doing, but I kind of got off track on that. So let's go ahead and we got dir3. So it's still doing it, right? It's still doing the exact thing. What happens if I comment this out? Anybody want to guess? What happens if I take this line out or don't have it at all? What's it going to do? Anybody want to guess? I'll give you a little time to guess. It's not going to run, right? It does nothing. It runs the program just fine. It doesn't throw any errors or anything. In fact, look, you can look at the error code. If you want to look at the return code of a program, it's a very special variable called $? And that will show you, whoops, you have to echo it. And that will tell you whether the program returned with an error or not. All right. Nothing came out. Yep. And so you'll see that there's no error. So 0 means in shell, if you've done any other coding in other languages, you know, 0 would be false. It might be a bad thing. In shell, it's not. In shell, 0 means the absence of any errors. If you ever had if you have a number other than 0, it usually means something went wrong, and the number is usually an indicator about what that error is, not always. So let's actually make, since we're on it, let's talk about understanding Grok shell return codes. We're going to need these return codes later because we can't talk about anything until we understand them, because that's what gives us conditionals. All right, so up here, let's actually lie here. Let's just return -1, right? So we put a return keyword. If you want to see what any of these things are, you can type return. It'll tell you what it is. If you want a specific thing and it's in a bash built-in, you can type help return. You can read all about it. Okay, so we talked about that before, but just a reminder, if you want to read about this stuff, help is right there for you. The help, because we're on the Bash interactive shell, is breaking down. This is literally the content from the man page. It's just not all 8,000 pages of it or whatever. I think it's 800 pages actually. So let's try our command now, right? Return can only return from a function or source script. So that's actually not it, right? Let's try exit instead. I made a mistake. I made a mistake. So let's do exit. I mix them up all the time. So exits the shell. Exits the shell with the status of n. If n is omitted, the exit status of that last command is executed. So let's add these to our commands covered. We've covered the commands. We won't put commands. Let's put covered. Let's say exit. We go functions. Okay, we did alias. Alias as we covered, right? We covered export. What else did we cover? We're going to cover exit and return. So this gives you a sense. The hardest part about learning any of this stuff is knowing what to learn. So having a list of the things we covered and go back and learn them on your own is important. Calling from go exec the bash command plus the rectify command and then your alias function. The bash command plus the rectify command. I mean, you could do that, but just make it just write it and go. By the time you did all of that, it would be fewer lines to just write the same thing and go. Because Go can do anything that anything a bash can do, and more actually. So that's why I'm kind of keen on moving. So anyway, let's try this. Oh, hey, look, 255. By the way, why is it 255 and not -1? We're going to come back to that later. Are there any computer sciencey kind of people who know the reason for that? Why is -1 returning 255? That's so weird. Remember this because we're going to come back to it. It's a single byte, right? Julian got it. It's a wraparound. So it's a single byte. Okay, so let's do the world's fastest. It's unassigned. Yes, it's unsigned. So let's do the world's fastest lesson and what it means to be a byte. So what are bytes and bits? And we're going to cover this when we do Go a lot, but we're going to do it really quick here because we have to talk about integers. Grok, integers, and integers, bits, and bytes. So let's say you're just doing this on your own. You would say, what is a byte? Okay, a byte is a unit of digital information most commonly consisting of 8 bits. Well, what's a bit? Cue my favorite 80s movie of all time. This is one of my favorite. This is normally from the lesson. I'm going to throw it in here. Did I go to Twitch? Force of habit. I got to do this fast if we're going to have fun with it. None of this is going to be. You're not going to be able to hear any. Oh, Bedazzled's on. Bedazzled's so great. Okay. Anyway, don't look at the screen. All right. Wait. I want to surprise you. So give me a sec. Don't look. All right. Wait for it. Okay, I know what. I'm going to play it. I want to see if you recognize it. Then I'll play it for you, okay? All right, you ready? See if you can name that movie. Okay, but again, it's not going to be in the YouTube, so you just have to suffer through it. Are you ready to look? This is the first computer animated movie ever. How much of this I can show? YouTube's gonna hate me. Even though that's fair use, it's probably enough to get YouTube mad at me. I hope not, but whatever. I won't be able to monetize that for showing it. That's a standard thing that I show every time. I've been showing that video since 2013. So what is a bit? That's a mnemonic reference to it. Okay, so how? It's an 8-bit definition. If a byte is 8 bits, so what is a bit? Anybody want to guess? Positive and negative, you're a bit, right? Positive and negative, you're a bit. So a bit is an on or off, and that is, and there's a famous scene from Mr. Robot in episode 2. Are you a 1 or you're a 0? Are you going to do nothing and be a 0? Are you going to do something and you're going to be a 1? You become a 1, right? There's like a really famous scene where, Mr. Robot talks to Elliot about that. So these are mnemonic references so you can know what a bit is. Bits formulate everything in the digital world, everything. So everything you're using, these streams are all going across across the internet in 1s and 0s at light speed. And she said, yes, no, yes, no, yes. And so, okay, here's a fun fact. So what's different about quantum computing? So all digital computing, I'm being very careful here. All digital computing depends on 1s or 0s. What is the fundamental difference between quantum computing and digital computing? It's a fun fact. Here comes a fun fact. Where's the description? Probably the best. Qubits. Yeah. That's fine for the spam. What's a qubit? What the hell is that? Then it's 4 states. Actually, I think it's 3, right? So the difference between digital computing and quantum computing at the very, very lowest level, as I understand it, and I don't know a lot about this, is that quantum computing looks at everything in 3 finite states: 0, 1, and I don't know. 0 to 1 fuzzy, right? 0 to 1 fuzzy, or 0, 1, and I don't know. And that allows guessing and operations and all kinds of things that are very much above my ability to explain, but it gives a completely different approach to computing. And if you have more horsepower, I mean, like we're talking a lot of horsepower and a lot of RAM, you can assume the third state about data, and you can start to do all kinds of things that you couldn't know by forcing something to be either a 1 or a 0. I find it interesting because quantum computing, I believe, is getting us closer to representation of the modern world and our physical universe. And in order to do that, we had to create a third state. And if you looked at anything about photonic entanglement or any of those things with like really tiny, particles, how they behave, it's super interesting stuff. So it's a big tangent, but the idea of a 1 or a 0. And by the way, has anybody ever heard about solar flares, bit flipping things? This is a thing. There's actually been cases where, outside influences have flipped a bit from 0 to 1 and changed some things. And why do you care? Because why do you care about all this, right? Well, here's why. I just did a -1, but I didn't have enough room on that. All right. And we are going to write a program in Go that counts from 0 to 10 in binary. And I don't normally want to do the whole base 2 thing right now. Should we do it? Let's just do the base 2 thing really quick. All right, so there's a joke here. I mean, this is all stuff that I normally save, but I'm going to go ahead and hit you with it right now. So we'll say this. We'll say, okay. There are All right, do you get this lame, nerdy dad joke? Area 1 or Area 0? Anybody get that joke? We had a few people get it. You can get this on a t-shirt. All right, so so this is the part where I usually make some lame joke about all your base are belong to us. Back to stream instead of dad jokes. There are 10 types of people in the world? Or there are 10 types of people? All right, so let's do this. All right. Let's do this. I guess we jumped all the way into this, so we're going to have to do it. Because we have to handle return codes, so you have to get it. I'm kind of glad we are, but all right. So let's say, let's put it in the README. So we're going to say, we'll call it binary base 2. All right. So over here, I usually do a lame joke about counting. I usually put one kid here and I put another person over here and I'm like, okay, we're going to have a counting contest. Okay. We're going to have a counting contest and I want you to count. We're going to keep counting. The one person can only use 2 fingers and the other person can use all your fingers. All right. You ready? All right. Well, let's start counting. But to be fair here, let's start counting with 0. All right. So 0. All right. 0. Great. All right. And then we get number 1. Okay. 1. And then the other person's like 1. Okay. We're on board here. And then you get to the number 2. And the person with 2 fingers or just no fingers, how do they count? They can't. The other person can put 2 fingers up, right? That is what base is. If you haven't learned base before, base is the number of digits you get to represent a number. And there's tons of different bases. All your base belong to. So base 2, otherwise known as digital, 0 and 1. So if we count, we get 0. And you guys know all this, right? This is going to be a little bit lame. I'm going to do it anyway. I don't care. So 0 and 0 are the same, right? We get 0 and then we get, I'm going to put this in one of these. So then we get 0 and so we get 1, right? And over here we get 1. And we actually will write a program to do this. And over here, So the only thing to know, okay, what happens when you get to 9, by the way? So let's do it over here. Let's make this one the first. So 2, 3, 4, 5, 6, 7, 8, 9. I have to explain this to people, okay? And then what? When we get to 10, we start over. Yeah. So when we get to 10, we start over. So here's how bases work. And by the way, if you've ever used an abacus, you know about this already, right? When we run out of digits, we add a digit and we start with, that first one. And so there's actually an implicit digit in front of all of these. And you can keep adding them there, right? There's an implicit digit in front of all of them for the 0, right? So when we run out of digits, we run out of fingers, we go ahead. And by the way, who invented our number system? Anybody know? Who invented our number system? Wasn't the Romans, right? By the Indians, it was a combination of 10 digits, value place system. Base centers, like, this is pretty. I've heard different stories on this. I thought I'd look it up again. Aliens of Babylon. Mr. CRC. Okay, so So there, right? Now, over here we have 0, 0, and we have 0, 1. So over here we get 9 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Over here we get 2 digits. So this is the equivalent of 9 in this system, which means that the next thing is what? And now you get the joke. The placeholder of 0 is a number. Did they really? That's super awesome. Right? So here we have 0, and then we have 1, and then 2. So now you get the joke. There are 1, 0 types of people in the world, those who understand binary and those who do not. All right, so what's 3, by the way? Let's try this. I know I don't go this long on this, but this is my standard lesson on binary. I just normally do it during Go, not Bash. Who cares? What's the next? Well, what would be next down here? Right? We'd add a 1 here, right? So now this is important because if you're looking at it, yeah, good. If you're looking at, if you're looking at these values and you don't know what the base is, if you don't know what the base is, you could have a lot of trouble. Yeah. Yeah. So there you got it. Good job. So if you don't know what the base is, you look at 11, you're like, no, this is not 11. This is 3. And then 10. Yes. Yes. All right. So let's keep going. So what's this? Okay. Now this is 11 is the equivalent of 99. Remember 1 is our maximum number. So what comes after 99? Right? So 4 is 100, and this is when we remember the chmod command with 644 and 755. This is all going to make sense in a bit. In a bit. I just made the greatest joke ever, and no one got it. They didn't think it was okay. Fine. All right, so I didn't even plan that. That's how good I am. Oh, sorry. Nerdy dad jokes. All right, what's next? Come on, tell me what it is. What is it? Let's get this over so we can move on. I mean, we're making progress. I don't care if it takes forever. This just saves time from the Go programming later. So, whatever. We're going to do base 16. Yes, we're going to do that. I bet you can guess. Normally, scissor, this is normally where we add that in. You got it. Next, okay. That's the equivalent of 999. So now what? All right, and then what? Okay, 10 what? 10. All right, see if you can catch up with me here. All right, so 10. I might get this wrong. So, did I get that right? We're not playing Dota. We're doing a boost, Panda. We'll play Dota after this, like 5 or 6. Chmod is octal. It absolutely is. It can be. It doesn't have to be. Chmod is octal. We're going to do octal next. Yeah. So then we do 1 1 0 0. Not yet. Not quite yet. Wait, did I mess it up? Oh, you're right. You got me. You got me. You got me because I'm going fast. I didn't say I was good. I know. I can't. I have to look at it. Thank you for catching me. So 1 1 1. Of course. Duh. All right. So that's why. All right. Hey. 6 is wrong. 6 is right now, right? Okay. Good. All right. So and now I know because read, write, execute, right? Let me just show you something really quick. So, look at these permissions. Boom, boom, boom. Right? What is 1? Let's put some zeros in front of here, shall we? You're going to understand the chmod command a lot better in octal after this. We don't have octal yet, but I'm going to show you octal pretty soon. So anyway, well, I mean, you know what? Not yet. Not yet. We need to do octal over here. Let's do octal over here first. Okay. So I'm sorry that I screwed that up. I was kind of not paying attention. So anybody ever seen a binary clock, by the way? Now, this I find interesting. So the number 8... Yeah, we'll get there. The number 8, good job. 1 1 0 1 0. 1 0 1 1. Let's go all the way to 16, shall we? 2. Is that right? 14, 15, 16, 13, 14, 15, 16, 12. Yeah, and then did I get this right? Correct me if I'm wrong. Am I doing that right? And then 16, which is actually on to the next set, if I remember right, is this. Right? Okay. Oh, there you go. You're cheating, Dar, already. All right, so let's stick with the 4 zeros, okay? Because that's pretty common. All right. I should be doing R0, stupid. All right, so, and by the way, a lot of times you'll see these ones and zeros like this. Sometimes people will call that a bit field. Thank you for the follow. Sometimes people will call this a bit field. Because what is it? What can you do with this? You can say, okay, I want all of these buttons. You can think of all these bits as like switches, right? And by the way, the ENIAC computer, that's how you programmed it. You literally switched on the zeros and ones. Look at the ENIAC computer. The very first computer, personal computer. That's how you entered stuff. Not the ENIAC. I'm confusing that. That's actually the first digital computer. I'm getting confused. What's the homebrew one? God damn it. I'm mind blanking. The Altair. Yeah, of course, the Altair. So the Altair. Okay. This is the Altair. So the Altair did not have a screen. And people will still use it. It would take them hours to put stuff into it. It's the first personal computer. That's not what I'm looking for. There we go. There we go. All right, so look at this. Tick, 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 tick. You know how you program this? I am not even kidding you. You program this by entering every bit of a computer program by switching on and off one thing. Can you imagine? There was no screen. There was no screen for this. It's like this. Look at what switches on and off. Okay, so it's really easy to go off into computer hardware engineering and talk about how transistors came to be and how they influenced all this. Transistors gave us the ability to store a 1 or a 0 while there was energy passing through it. And that allowed the creation. And the ENIAC was the first digital computer. And if you want to get really crazy, go read The Innovators, which is my favorite book from Isaacson, the same guy who did the documentary on Steve Jobs. And you'll learn all kinds of amazing things about this if you like this stuff. I'll put it under here related. I'll put The Innovators from Walter Isaacson. Mandatory reading if you want to really understand the world of technology today. It's really amazing. I'm only about halfway through it. I keep getting sidetracked because I keep reading it over again. Anyway, so, I mean, we spent a lot of time on this, but this is really fundamental to these return codes and to these things that we're going through. I normally don't like talking data types this early, but you really kind of have to hit them early. It's really important that you understand that every single thing that passes through the brain of a computer or gets stored on disk is base to binary in a digital computer. And if you really, really want to get crazy, you can kind of see how, Alan Turing invented the way of computing in general and how it works. And I don't want to get into that. That's computer science. Very interesting. But all we really care about from a practical perspective is what do these numbers mean and why do we care? The Turing machine. Yep. But that's all computer sciencey kind of things. Interesting, but not really useful in terms of like work. But for work, you do need to understand what these are. You need to understand what the binary things are and what these different bases. So here we have base. This is base 10 over here. This is because we have 10 digits, 0 to 9. This is base 2, otherwise known as digital. Thank you for the follow. And over here we're going to have something called base 16, right? And let's just stick with the base numbers for now. Somebody's already got it for us. So we have 0, right? So if I have 16 digits, yeah, the Netflix on to Alan Turing is really good. I like it, actually. I watched that. It's kind of sad, actually. Alan Turing had kind of a sad life. It was amazing, but he also had a very sad life. He lived at a complicated time. I want to start educational streamers. What should I do? We'll talk about that during the break. Okay. Let's talk about that during the break. We have how many minutes? 19 minutes. Okay. Drop the 16. Base 16. I'm a computer science teacher by degree. Nice. Well, you could really help. We'll definitely talk about that. We'd love to have computer science as an education. That's not my thing, but okay. So here's the thing. Anybody ever done colors? Anybody ever done? I like to show people practical examples of stuff while we're doing it, and so they don't just think that we're just talking about it. Okay. Anybody ever done colors? So here's RGB. Okay. So here's let's do an RGB color generator. RGB color picker. Right. Look at this. We have RGB. Here we have 50 and we have 168 and 82. So why am I showing you this? Because I want you to understand that knowing about base 16 and base 2 and octal and all this stuff is essential for doing coding. You have to know it, even if you don't want to understand how the computer deals with it underneath. So here we have RGB. But here, look at this. This is hex. Well, what do you suppose that means? First of all, what does the Latin hex mean? Where does the term hex come from? I guess I'm doing my whole type lesson right now. Why not? It's fine. What is hex? Hex is base 16, hexadecimal. But what does that mean? What do the Latin roots mean? And I'm a big person. What does hex mean? And what does deci mean? Hex is 6, right? And deci is the Dewey Decimal System. Deci is what? Hex. Deci is 10, right? Decimeter is 10, right? Okay, so hexadecimal, so 6 and 10 or 16. So when somebody says something is in hex, what they're saying is they're using base 16, which means what? They have 16 digits, right? And how do those 16 digits translate into numbers, into digital numbers? Well, if you look at the RGB value and you look at the hex value, but the first thing you're going to notice about the hex value is we got this letter A in there. What's that about? Well, that's because we don't have enough fingers. Okay. So, and this confuses beginners because they're like, what the hell? There's like letters in my numbers. Who put their chocolate in my peanut butter kind of thing. It's like, that doesn't belong there. What the heck? And by the way, usually this is in a bad font and you can't tell whether it's a 0 or an actual number, right? Yeah, good job. So then we have 9 and then what? Do we have 10? If I have hexadecimal, do I have a 10? Yes or no? We have other advantages. We don't have a 10. No, thank you for the help. We have an A, and you can use lower, upper. People use both all the time. B, C, or we could say alpha, beta, whatever. A, B, C, D, E. This is my All Your Base Are Belong to Us lesson. E, F, G, right? Do I have a G? Can I have it? Vanna White, can I have a G in my hexadecimal? No, why not? There's no G. Okay, so you made your point. What do we have, though? What do we have? So what is it? What's 16 in hexadecimal if I have a G? Ah, yes. So now, if you want to expand on your nerdy dad joke up here, you could say there are 10 types of people in the world, those who understand hexadecimal, and then you can like have 16 of them. Because look. Yeah. So what I want you to see here, though, is look at this. So here we have, 10. We have 10 over here. So the decimal number 10 is the binary or the base 2 number 2, And it is the hexadecimal number 16. But I'm going to make it even harder for you. Because guess what? There's another one. No, you thought we were done, right? 5, insert, space. All right, sorry. Because there's one in here that we forgot, and I know we're going long, but we're doing a whole Go lesson here instead. So 10 comes as the base resets. Yes, 10 is always when the base resets. Yeah. Very good. All right. So what do we got here? We got 0, right? So let's pretend we only have 8 digits, otherwise known as octal. Okay, octal. Let's pretend we have 8 digits. 1, right? 2, 3, 4, 5, 6. Damn it. This is hard. I can't do this. All right, wait, there we go. 6, 7, 8. Uh-oh, we're out of digits. Now what? Now what do we do? What do we do? And octal gets used all the time. Why? Because how many bits are in a byte, my friends? And this is going to get us back to our bash programming, I promise. Use your toes. 0, 1, 2, 3, 4, 6, 7, 8. There isn't an 8, is there? Exactly. Isn't there an 8? There's no 8. Oh, what do you mean there's no 8? It's octal. It's supposed to have an 8. There's a new bit, of course. Okay, so boy, I can't troll these people. They got me. So 8, there's no 8 in octal, believe it or not. There's 8 digits, but they start with 0. So what is the moral here? The moral here is that 0 is a digit, my friends. 0 is a digit. Okay, so we don't have an 8 here. We have a 10 here. All right. So we have a 10, and then we can keep going if we want. I mean, it's probably obvious for you at this point. So it'd be 11. I mean, I don't know. Let's try it. 11, 12, 13, 14, 15. I'll fix it. 16. Do we have a 16? Do we have a 16? 17. Do we have an 18? Oh, we don't have an 18, right? We don't have an 18, though. Why don't we have an 18? Because there's no 8. Yeah, 20. So this looks a little bit confusing, but this is important that you get this, okay? We have 20. Yeah, thank you. We got lots of help here. So this is how you count. So the 10 can mean 10 in decimal. It can mean 2 in base 2. It can mean 8. This is super important. It can mean 8 in base 8, octal. Or it can mean 16 in base 16. So we'll go back to our little thing here. What if I change? So if I change this if I change A8 to 1/8, is that going to be higher or lower? If I change the A, stop it, PMT. So let's do 1/1 here. Oh, wow. We got a really different color, right? So what I'm trying to tell you here is these hexadecimal numbers in colors, and when you do this, there are 3 different hexadecimal numbers, right? And those hexadecimal numbers their equivalent are in RGB down here. So if you wanted to see, so 32 in hexadecimal is 50 in decimal. 11 in hexadecimal is that right? I don't think is that right? Is that right? 11 in hexadecimal? Yeah, that's right. So 11 in hexadecimal is 17. See, it's off our chart here. 10 here, and then it's 11 here, right? So, and then 52 is 82. So you really, the reason I did this is you really have to know. There's actually another one called base 64. Let me show you base 64. You're going to need to know base 64 if you're going to be a hacker, because that's where all the encoding happens. UU encoding, base 64, and there's base 32. But you're going to see all kinds of encodings if you want to go into hacking, right? Base 64 encoding is the most common way to take digital data and turn it into text. Can anybody think of a thing where that happens all the time? This is super important if you're going to do operations. Can anybody think of a time when that might be a thing? This is an image converter. So let's say you want to send an image over email. This is true. Every single bit of binary data that is sent over email is converted into base 64 or bin hex. It's similar. Okay. And another thing that's in base 64. By the way, in base 64, obviously they run out of numbers, right? So what they do, look, I'll show you the base 64. Base 64 uses a bunch of numbers, and then it uses a bunch of letters too, and then symbols, right? Base 64 table. I want to show you this really quick. So here is the base 64 table. So, base 64 index. The thing I always find funny about this is that the letter 0 is 52 for some random reason. I don't know why. Okay, this is easier to read. Let's read this one. No, that's a little bit easier to read. Can I zoom in on that? I'm trying to find a good one. I mean, you can find them. You can go search for them. Yes, it does. It has lowercase and uppercase. See? So an A is binary 0, a B is binary 1, a C is binary 10. And then, so anyway. Yeah. So when you take, digital data, I mean, binary data, which is like images and things like that, base 36. Yeah, me too. Yeah. I've written my own. I actually wrote a whole library about this if you guys want to see it. You guys want to see it? Yeah, I wrote a whole library about this in Go. So this is how, if you want to create unique number, hey, thank you for the follow. So this is my package. It's called unique, and this will generate, different hexadecimal stuff. It does base 32 as well. Base 32 is a really good encryption standard. Encoding standard. Encoding and encryption are different, my friends. Encoding is how you represent the data as text or whatever. Encryption is, the science of making stuff hard to figure out, and that encoding and encryption are not the same. People mix those up. So this is 8 bytes, but you can actually use this command to do all kinds of stuff. Anyway, so Z unique. So Z unique hex, not enough arguments, hex 4. So this gives you 4 hexadecimal characters. Let's do 1 hexadecimal character, with 1 random hexadecimal character, and UUIDs and everything like that. So all this stuff, I mean, you guys have probably seen a UUID before, right? This is a UUID. This is, can you guess what the encoding is? So yeah, absolutely. This is very useful for generating passwords. So at SKILSTAK, the standard for user IDs that I made was hex 3. And then everybody would get a unique ID, and that would be their unique ID, which would also match to a color. So all of my users had a different color. And I know that that's a very finite number set for, like, I would never do that unless I knew there was only going to be 1,000 people total. But you know what I mean? It's because of the uniqueness. I have to make sure there were no conflicts or anything like that. So you can use these, but more importantly, how does this stuff get used? It's kind of a fun, because then every single student had their own color, and they could change it, and then they could, they could kind of remember and things like that. So it's kind of fun, because then they're like, oh, and they get to study, bin hex, and they care and all that. The colors probably say they did, actually. People would get like poop brown. They like, want to change their color. I'm like, it's your ID. You should change. And I started showing them their color up front. When they figured out it was the color, they kind of got mad. I didn't let them change it early on. So, but you'll never forget. I mean, hopefully this will be a good object lesson for you. So, but, as usual, we're going to be practical here. Where's another place that bin hacks is used a lot? The dog is trying to hide. My dog. Okay, fine. Come in. It's thundering outside, and the dog is hiding under my legs now because it's thundering. Last time we got killed by the thunder that time. Anyway, so this is used all over the place. Okay, and now you know what it is. Now you know that it's just another way of representing ones and zeros. That's all it is. So we kind of moved from bases to encoding. There's actually some really important places to show you this, though. So we remember when we did SSH? Okay, be careful what you show here, because you might end up giving away your private key. So if you're a streamer and you ever show this key right here on stream, you need to immediately change all of your security settings, because somebody will break into you like that. Okay. So before I do this, I want to put that out there so that people know to be careful about that. It's actually not that dangerous once you just go change it. You just have to go change it. But the reason I'm showing you this is I'm opening up with VI. This is my public key. So this is a public representation of my digital key, my digital unique 1s and 0 combinations. And it uses hexadecimal, I believe. Actually, no, it uses base 64. So it uses base 64, and look at that. They even use the plus symbol in there. Because two X character fit into a single byte perfectly. Yes. Yeah. And 64 has uppercases. Yes, base 64 has uppercases and lower cases. So this isn't a case. Another place you would see this is if you started to use certificates. So if you're going to get into Kubernetes, Kubernetes is all about managing certificates. That's if you're an administrator. You have to know what the certificates are. If you want to GPG encode something, you know, if I wanted to GPG encode this README, I could GPG README, and trying to guess what you mean. I forget what it is. Is -E. Current recipients and with empty line. No user ID. Anyway, I mean, GPG has encryption. I don't want to do it because I might dump my keys on accident, and I don't want to do that, especially my GPG keys, because you can't take those back easily. Anyway, so this is, I mean, we got into a lot of here, but this all started because we were doing bash return codes, and we saw something weird. All right, so now you should feel confident understanding bits, bytes, bases, and we're talking about decimal. Is it decimal? It's all right. Decimal, octal, and yeah, decimal, octal. No, binary. Binary, decimal, octal, hex, and base 64. I mean, there's a lot of them, but those, you should definitely understand that. All right, so why does all that matter, and what is all the thing about it a bit? Okay, so back to our program. So a number is in the, so the computer assigns a certain number of bits, which are 1s and 0s, for each size of a number. And this is going to become really important when we do Go coding. But the reason that returning a value of -1 is 255 is, what if I were to take this number? Let's see. So I'm going to try to do that. I'm going to mess this up. Someone help me. So what if we were to take this 3, 4, 5. Actually, let's put this in the README. Okay. So, yeah. 1, 2, 3, 4, minus 1. Actually, no, it would be, oh yeah, it's one, actually 1/2 a byte, isn't it? Oh, it's a pub key, right? So, yeah. Yeah, those are my pub keys. Wow, that's cool. I didn't know you could get that so easy. That's really cool. I probably should delete some of them. 3Z crowd. Yeah. So that must mean it's a short, right? So that means I didn't realize that. Yeah. That means it's like four digits. Yeah. So it gives so what this means, the computer is saying I only have 4. Actually that's not true, right? It would be like this. It would be like this. Yeah, okay, so the reason there's an extra one here, and this is what people don't know, is that this one right here is plus or minus. I wonder if I can do that. And we need a plus or minus. What is that symbol? So it's called signing. It means a number. It means they have 3 bits to represent the number, which is why the maximum number is 255. But they saved the first spot for a 1 or a 0. That means it's either negative or positive. So that means there are 4 there, but when you take one away from it, it doesn't, since it's it changes it. Is it 8 bits? Are we sure it's 8 bits? 255 is 8, right? Help me out. I don't do binary math very much. This is the only way I would go for this. So why is exit minus 155? Well, first of all, what is 255 in decimal? What is 255 in decimal? Right? And if you want to, you can go through, you can go find a converter for this. I'm going to show you what I would do if you didn't know better. Decimal converter. So let's do 255 is 255 in decimal. Did I say decimal? I meant binary. Base 2. How to convert? Okay, decimals to fractions. No, we're not doing that. God, no. How to convert decimals to fractions? How to convert? You can kind of do it on the command line too. You can change it with base. I was just going to use BC, but I don't use that for conversion very often. Does BC have? DC has it. I know DC does. I don't know if you can change it. Can you change the base in DC? I want to learn how to do that. I want to learn how to, because I want to learn something. Man, BC. Arbitrary precision numbers. Browser console. Yeah, we can do that too. You can also do it in Go. O base equals 2. Ah, yes. O base equals 2. I've been wanting to learn this, so yeah. Thank you for teaching me that. I've been wanting to learn that for a long time because that's a nice, easy converter. I don't have to use Go for that. That is fantastic. Oh my God. Thank you so much for teaching me that. All right. So, I knew you could, I just have never done it. I don't really do it. So let's say use O base equals 2 to convert to binary from decimal. Is it E or? I always spell decimal wrong. That's really cool. All right. So yeah, let's do that again. I want to do that again. So BC is the calculator, right? You can also set scale, like if you wanted to, like if you do like fractional math, right? So you could do scale equals like 6 and do the same thing. And it's got history because it has read lines. So you can push up an arrow. Oh my God, it's got VI mode because it's read line. It does. You can do escape and go through the history because it's read line. We got to show everybody set-ovi after this. That's super cool. Okay, so, all right, so O base equals 2, which is binary base 2. So let's do, what is 8 in base 2? 1000. What is 2 in base 2? What is it in O base hexadecimal? 16 equals 16. What is 2 in base 16? It's just 2. What is 16 in base 16? It's 10. Okay, so what is 255 in binary? So let's go O base 2 and let's do 255. Whoops. Oh, it is 1 byte. Okay. Yeah, I don't know why I mix that up. It's because every time I talk about the ASCII tables, it's like the first half of the ASCII numbers are thrown out. I keep thinking that's related to integers. It's not. Yeah, base 16 is times 10. Yeah. So there we go. There we have 255. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 of these things are all on, right? So what is -1? Oh boy. That's because it didn't wrap. It's because it didn't wrap. No, it didn't. All right, so we're going to have to exit that. Control C. Control D, I guess. All right, so back to what we're doing. Anyway, the long story short is that instead of, oh my God, -5 homo. All right, let's take a break. More Linkin Park. Should we do more Linkin Park? Actually, we already did the Linkin Park. Let's do Devil's Playlist. No, that's kind of mean. Yeah, no, let's do Devil's Playlist. Devil's Playlist. Let's do Lick from Rebel. All right, time for a break. I got people that wanted to ask me questions on the break. Do you want to listen to music? Ask me questions, okay? I'll put music on anyway, though. Oh. Somebody asked me questions. Ask me your break questions. Let's do an 8-minute. Turn down 8 minutes. Little cat. Starting an educational stream. I mean, that's kind of smaller, but whatever. All right. We'll leave the music for the others. Oh my God, that's really loud. I know. Do you want to talk or listen to music? I'll leave. Can you still hear me? We'll leave the music on, other people can talk. Can you? Tip number 1, have really kicking music during the breaks. But make sure it doesn't go in your VOD because you'll be banished. Oh, poll on experience. How many years of experience people have in coding, if at all? The problem with that poll is I have to actually put the number in there. Make live coding educational streams. Oh, fantastic. Yeah, I can't wait for you to do that. I can't wait for you to do that. I really want you to do that. The 2's complement representation for signed numbers. You flip all bits, and then it becomes all zeros, and then add 1. I didn't realize that. VMT. Yeah, we'll have to put that together. I didn't realize that was what was happening. I mean, I knew it was wrapping, but I didn't realize how it was wrapping. So. Yeah. All the zeros and then add 1, yeah. And the 1 is the sign, and since there's no signing, then it chucks it. This is my fiance gets her set up my office. We got a lot of great people in this community who integer representation with mine was a happy accident. No, they did not mean to do that. There's been so many flip bit problems like that. The overflow errors on integers are really, really common. So yeah. How would you get started? The first thing I would do is I would establish whether you're just going to be streaming from the desktop or you want to be able to walk around. And you might not think that you want to walk around, but you might realize that in the end that you do, like I did. So after your first year and a half, let me turn my music down just a bit. I mean, I love the music, but so I mean this. I mean this is something I've learned after 2.5 years at this point, right? So when I first started streaming, all you could see was my screen, and I was too chicken to be on the screen and blah blah blah, trying to hold my identity and be private and all that. I threw all that out after the first year. And I had run a company before doing education for coders and stuff like that because nobody was doing it. And I went online. So my quick story is that I went online to start doing the same thing that I did at SKILSTAK, you know, learn code, change the world kind of thing, right? But a lot of people suggested I just keep doing what I was doing, just do it online. And so I pretty much had the same method, and I'm a one-on-one mentor kind of person. So I had to adapt and try to do the boost or something like that in a way that I get to pretend that you're with me one-on-one. And it's been, completely uphill learning process since then because, everybody's different. I do different curriculum every week. I mean, every year. The number of bits allocated to each numeric type and whatnot. Yeah, I think that would be really cool. We're really, really going into the low level bit thing. And I do want to take us there to a degree, but I don't want to get too crazy with it because I still want to code in Bash. I want to keep it practical. That's one thing about my boost in the SKILSTAK organization I started was we're always practical. We're not so much about theoretical. We're always practical. Like what's going to get the job done? What is the minimum I need to know to understand what I'm doing? And that doesn't necessarily mean starting with data structures and algorithms and, Turing complete programming and stuff like that. But if somebody else knows that stuff, I really want to I would love for that to be presented because I do think people want to see that because they're being taught that in college and they have questions and they don't know where to go to and stuff like that. Yeah. So in terms of getting started, I would just, if you at all are considering doing IRL streaming, I would invest in a good camera. And when I say good camera, I would get the Sony, like the one I have now, and I would get the Camlink encoder. But how shall I say your name? I ate Punica. I ate Punica. I ate Poon. Punica. If you're gonna do, so here's stick around. So I do a lot of IRL streaming. That is not the boost, and I'll have more than 5 minutes to talk to you about this. If you have questions about how to do this and you want to do it, I stream a good 3 or 4, 5, 6 hours a day, not doing educational things, just like walking around, skateboarding, or watching sunsets. And I can gab and talk all you want about whatever you want to do. I would love to help you if you want to start streaming, particularly if you're going to become an educational streamer. I would personally love to really help you get going. I don't believe in scarcity mentality. There's a lot of streamers that won't help each other out because they don't want competition, which is just stupid to me. So yeah, and I can help you get started. You don't need a green screen. Number one gabber in the USA. I do a lot of talking and randomness. I mean, just watch the VOD last night. I mean, we did everything. We played guitar. We cleaned my room. I cleaned my whole room last night. A competition breeds innovation, absolutely. And also, scarcity mentality is a myth. There's plenty to go around. If we had 15 people coding in Go, it would still be okay. Right? So that's all I have to say about that. We're going to get back here and at this in a bit. We only have 1 more hour left. How much coding do we get? Here's the cool thing, though. We can actually do conditionals now. You're pretty sure that I'll be doing... What, is that you? Who is this? Is this your next account? Oh, this is your techie account? I thought about doing that. I thought about having a separate tech account and I guess if you're a teacher, I could see doing that. Have dedicated content. The more generalized wisdom for streamer dumb is that you should have one stream only. Unless you're like really, really putting a character together like Belafonte, like she does. Unless you're putting a character together. You're gonna get me in trouble. You're gonna get me in trouble. Don't refer to that. It's gonna be saved. People are gonna read that and they're like, "Why are you being mean?" Don't get me in trouble. On that note, let's move on. So yeah, if you want to talk more about getting started, let me know. I mean, as an educator, I can talk about it more than somebody who just plopped down and started Twitch streaming. But I have also kind of integrated with the more mainstream Twitch community. Some might say I sold out, No, I think that this platform is phenomenal for all kinds of things. And for totally selfish desires, I want to meet more people. I have expanded my community from being just software and ops to music and just chatting and skateboarding and doing outdoors, and Dr. WD, who does bird watching and he's a professor. The people so the reason I do Twitch is very selfish. It's because of the people that I've met here. And I mean, I have I have a full-time job to pay for my expenses and my really, really expensive IRL streaming habit. And so that's why I'm here. And if you don't have to be that though, I mean, you could be like Strager and just, 100% laser focused on coding and technology. And that's fantastic. We need people that want to do that. Or you could do, just OPSEC. And if you want to do it like others, or do variety, whatever. The mainstream, wisdom from Streamerdom says that even if you are just a geology streamer, like, Rocket Sage, who I watched her for like a full hour last night. She was like, she was kind of throwing shade at an old documentary and just like being really pedantic about it. It was awesome because she just really knows her geology. And I was watching her, and there's only 50, 60 people in there, but it was really amazing, because she's an educator and, but she's integrating with everything. And then, by the way, reach out to the Knowledge Fellowship. It's an organization that's come to me and asked to, tell people when I'm streaming stuff. I feel bad about it now because I might be, I don't know, like trolling dance clubs, and they're telling, go check out Rob, where you can learn about all kinds of things, like how to troll a dance club now. I feel bad, or whatever, it's like, so anyway, let's move on. We only have an hour left. As you can tell, I'm kind of descending into madness. This whole entire last hour ended up being dedicated to binary, bytes, and stuff like that, and what a number is. And I'm kind of glad we did it at this time. I was trying to put it off until we go programming, and then I realized we're going to have this because we're going to need to deal with what comes out of a thing. What are the statuses of a thing after it runs, and exit, exit codes, status codes, and these are integers, these are numbers. And so what's the difference between a number and a string? I was hoping we could get away with not covering that in Bash too much. It's because it's so loosey-goosey, but we really do need to cover it. So I'm glad we did. And that's just going to we prolonged some more Bash learning today, but that has going to really fast forward our Go programming when we get to that as well, because it has all that same stuff. So there are two primary data types. Actually, no, there's a third data type in Go. I'm sorry, in Bash. And correct me if I'm wrong on this, but when I say data types, right? Understand. So Grok, Gork, Grok data types. And we'll say Bash data types. Now, there's actually a lot of data types. So I'm going to put basic Bash data types because these are basic Bash / shell data types. All right. And they are number, more specifically integer. Okay. Yeah, I know. I don't want to, I'm trying to avoid it. String and Boolean. And some of you, if you're brand new to coding, you've never heard of these things before. So a number is just a number, and integer / float. And there are no floats in Bash. Okay. And so remember, there are no floats in Bash. And if somebody from the Z-Shell community comes and tells you that's why Bash sucks, we're going to talk about why that's not true. Just to remind you, a float is a decimal. If you know anything about math, it's like a number with a dot. And the dot actually can consider floating point. In the old days, you had to buy a special kind of computer to do floating point math. Anybody old enough to remember that? Anybody old enough to remember when you could buy a computer, a TRS-80 or whatever, and you could buy it either with a floating point processor or without? I'm really dating myself here. Raise your hand if you dare to admit that you're old enough to remember when they sold computers with or without floating point processors. Because they did. They did. Or total flops. They actually did. They did. They tried to sell them with or without them. Which was really stupid because you need floating point math. Floating point math, by the way, computers suck at math. They suck at it because they can't get precision right. Okay. So when you do 1 divided by 3, how do you stop? How do you know how far to go? How do you know how many digits to use? Well, a mathematician on paper can say, I only want 4 digits. That's enough for me. But the computer has no way to know how far you want to calculate it. Right? And that's a really, 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 really big problem in computer science. And we'll get into it later. But when you're doing programming, you could actually do division that you think like 1 divided by 2. And if you do it wrong, you might end up with something that's not 0.5. You might end up with something that's 0.499999999. And if you write a conditional that says if the number is 5 or above, guess what? You fail. Because the floating point math processor has screwed you over. This is one of the biggest sources of major bugs in software throughout the ages. You just go back and do a search on it. If anyone wants to write a paper on it for school, it'd be really kind of fun. Like banking errors and all kinds of errors like that. So you need to think about integers versus floats or decimal. Okay, so in computer terminology, they call them floats because you can think of the period, mnemonically to help your memory. You can think of the float as being the period floating around in the number, right? That makes it a float. It's a float because it has a dot. Okay. Rockets have crashed because of these errors. Yeah. I would love for you to document it. That would be really great to add. I am in the middle of my session. I have 44 minutes left. What would you like, my dear? You're going to order pizza or something? No. You look like you're going to ask for something.
If I go to Alfred in Alfred, New York, which is a high walkability, livable, super cute town I looked into, we would actually save money. You know what the median house costs?
In Alfred?
There?
Yeah.
$120,000.
What?
Here it's $320,000.
Yeah. Let's go buy it.
It would be in our financial interest to move there.
Okay, let's move there.
Like 2-3 years.
Ready to go. Make it happen.
I'm also looking at University of Connecticut.
Okay.
Which is in Storrs, Connecticut, which also is a lower cost of living than here.
I agree.
Chapel Hill is actually higher. It would cost us more to live.
Oh yeah, absolutely. It's a college town. It's got Raleigh and everything.
But they all are college towns.
No, but it's got tech hub.
Oh well, yeah, it's a tech.
That's why
that
it's.
would be the benefit for you.
Oh God, yeah.
So that's where I'm thinking of.
I don't. It doesn't matter. I can work anywhere.
Greensboro is also a possibility.
I'm sorry. They're in the middle of a lesson. They're like, we're talking about floating point math, and that's my wife. I didn't lock the door. She keeps forgetting that I'm doing the boost right now. She thinks she's so excited because she's planning where she's going to go next. I'm sorry. I promise. I'll give you back 10 minutes after that. Artemic's wife. That's my wife Doris, who is getting ready for her MFA. She's decided not to go to Spruce Pine after all. News at 11. Love that woman. Absolutely need to interrupt the boost. It's my wife. She shoots from the hip on everything she does. Yeah. What were we talking about? She's also extremely cute today. So it's like really messed my brain up because she's just come in here and she did a little hip thing. And I'm like, oh, my honey. Is she into CS? Hell no. She taught herself C, though, so she could do robotics in her artwork. Not even kidding. She's brilliant. She's the best. I love her so much. What were we talking about? We were talking about floats and stuff. And this is, by the way, if you don't like interruptions and random IRL things and dogs running under my feet during the thunder, then you're in the wrong channel. And if you're wondering whether or not you should isolate all of those things from your stream to be more focused, I think you're probably doing Twitch wrong. You probably want to like build something and put it on YouTube or something. That's not what Twitch is about, randomness. I see to do my job. Yeah. Okay. So let's keep moving. Floats in Bash. Okay. So numbers. We're talking about numbers. There's two types of numbers. Numbers that are whole numbers, 1, 2, 3, whatever, and 1.0, 1.1, 1.2, 1.95, 3.7, whatever. Those numbers are, and by the way, that's why you don't need a green screen. So don't even bother. They would rather see you in your environment than see a green screen 9 times out of 10. So that is the difference between the different numbers. Okay. I'm going to say this one more time. In Bash, you cannot do floating point mathematics. The reason that I was geeking out on BC, and we're going to get to this, is because the BC program is a program that serves as a Unix filter, and you know what that is now, right? Which allows us to do floating point mathematics. And if you are not using BC to do your floating point mathematics, and you're depending on Z-shell floating point mathematics, you're doing it wrong because it's dangerous. And we'll get into that later. But let me just show you how to do math. And if you're going to do math, you can do. I don't think they had a floating point. You're missing out. Yeah. So BC. So we can actually do this. We could say scale. Scale equals 2, right? And we'll say 1 divided by 3. And we're going to run that and bang, bang, and we're going to run that whole line through Bash, and then we get nothing, right? But if I run that through BC, I get a value, 0.33, okay? And you can do all kinds of fun stuff with that. So if you're going to do, by the way, if you want to put that into your code, you could put it into here. So let's go ahead and do that. Let's say I want that value. So I would say I want 1/3 equals, right? And remember our variables are defined like this. And we're going to say BC, let's see. I wonder if we could do it a couple of different ways. Let's try it with, well, I'm getting ahead of myself. Just know there's numbers, okay? There's numbers, there's strings, and there's booleans. And boolean is a true or false. And string is just a number, numbers, letters, and all sorts of characters all together. So we already did that one. So name equals Rob Muehlstein, right? If you want stuff to be combined, you need to put quotes around it. If you put double quotes, it will do expansion. So if I put ls here, you'll get something weird, right? Echo name, and you'll see something very odd. But if I do that, you'll see, oh, look at that. It put that stuff inside of there, yeah? So that'll expand it. If I put a single quote here, what do I get? I get that actual stuff in there. And when we defined an alias earlier, that's why we use single quotes. So the moral of the story is, grok difference between single and double quoting strings. Okay. There's no other type of quoting. If you're used to that, thank you for the follow. There's no other type of quoting, like backticks or something, like, formatting strings, stuff like that, like other languages have, if you know about that. So that's it. So that's a string. We covered strings. Let's try numbers though. So here's something interesting. Let's say name equals 1, echo name. Now my name is going to be 1. Is it going to work? Yeah, it works, right? But it's technically, is it a number or is it a name, right? What if I want to say true? Okay, now it's going to say true. Interesting. But is it true or is it false? Right? Well, we're going to get into that later. What I just wanted to show you is that you can do this. Now, one other thing you can do with these basic types is you can declare them And there's two forms of declaration in Bash, and a lot of people don't know this. So there is something called declare, and declare goes back quite a ways. Declare, set variable values and attributes. Declare variables and give them attributes. If no names are given, display them. We covered this a little bit last week. Restrict action, display functions, lots of stuff, global variables, blah, blah, blah. And there's also a thing called local. So help local. Now local you can only use inside of a variable, but it has exactly the same stuff. So should you use it or not? If you're writing a script and you just want a quick and dirty one, you probably don't need it. You can just do name equals true and just know it's going to be a string, right? And not an actual value. But if you wanted to say like declare, I think dash B, and now we can try it. And we could say, let's do this. Uh-oh, I did it wrong. I don't know about Boolean. Let's try numbers. Dash I know that one. I know that one's true. So I don't know why I would have a name that's a number. That's stupid, right? But if you wanted to, you could do that. So there's still one, right? But why does that matter? Because let's say, remember that whole exit thing that we just did? Watch. So exit. We're going to exit with 1, which, by the way, what does 1 mean if we exit like that? What exit 1, what does that do? Does that mean success or failure? Echo. No. Okay. Does that mean it succeeded or it failed? It failed, right? Because we had 1 error. 0 means there were no errors. 0 means there's, or -1 or something like that. So there's nothing, right? There's no errors. Okay. But what if I wanted to put that in a variable? So I say about return value, really common thing to do this. And I say exit RV. Is that going to work? Let's try it. Well, it did. It worked. Okay. And that's because Bash is actually pretty good at figuring out what the thing is. But there are ways to confuse it, right? So if we do it like this, we still get a 1. Let's try. I mean, Bash is still pretty good at figuring it out. So I don't know. Let's try a 2 and see what happens. Let's try a 3 and see what happens. Okay, that seems to be working. So we might not. I think Bash is better than. I wonder what version I'm in. Shell in general doesn't always do this. It doesn't always infer. This is called something called duck typing, by the way. So I'm trying to cram a lot in this last minute. Grok, duck typing. What's duck typing? What's duck typing? Duck typing is if it looks like a duck and it quacks like a duck, it must be a duck. So this is an example of duck typing. Duck typing is really, really bad for production enterprise systems, but for this case, we're fine, right? Because they wanted to write code fast. Shell scripting is right for writing stuff fast. It's not for writing stuff that's going to have a high sustainability and long term, depending on the situation. So this looks like a 3, so it looks like an integer. It's like, okay, I'm going to use it as an integer. So RV gets defined apparently as an integer type. Although, how do you do that? Do you guys know how to? Here, let's do this. Let's do set dash. Is it X? I think it is. Yeah, there we go. Okay, it shows you all of your stuff. I'm trying to. There's a command. I don't know Bash well enough for this. Does anybody know a way to check the type of a variable with a command in Bash? I've never figured that out. I'd love to figure that out. Anyway, so I would love to be able to stay the type of that. You can't do type RV because it'll just do type 3. Yeah. It's just going to say the type of 3, right? I don't know. I've never seen that. Declared SP? What is that about? Man, declare. Help declare. I mean, there's always more to learn in Bash, I swear. Display the attributes and value of each name. Oh. Declare dash P RV. Oh, I'm happy. I'm loving this. If this works, declare dash RV equals 3. Oh, so it's using 3. It's interesting. What's declare dash do then? That's cool. I learned something today. I've never done that. I am so glad I asked. So help declare dash p, display the attributes. Turns off the given attribute. So dash dash, what does that mean? It's not setting it as an integer though. This is totally different than Python or Perl or anything like that. But, and you won't really need it, but you're definitely going to see declare around. So now you know enough to make names have the integer attribute. So this one you have to use. So bash 4 and above support associative arrays. That's key equals value pairs. This is super cool. But you have to declare them. You cannot just have them inferred. You have to declare them. Dash A is inferred if you do it right. We have, these are complex attributes. These are complex data types that have, their collections and stuff like that. We'll get to them in a second. Like bash 4, me too. Bash 4 is phenomenal. I use associative arrays all the time. You can't have associative arrays of associative arrays though. Saves you from putting all that stuff in a file, which is what you normally would have had to do before. To make names have the integer attribute. So declare dash I is pretty common. Local dash I is pretty common. Why? Because it forces it into an integer attribute. So if you have any question at all about whether that value is going to be a number, you can do dash I and it'll work. So I think that might come to play when, Christ and POSIX shell, I know. To convert the value of each name to lowercase on assignment. I didn't know you could do that. That's new. I would use parameter expansion for that. Make name a reference to the variable name by its value. Oh, right. This is how you do dereferencing. This is super cool. So you can actually pass around the name of a variable and then evaluate it sort of. It's actually not an evaluation. I'm kind of geeking out here. This is very selfish because we have beginners who don't know what this is. But so let's go back. Yeah, we'll come back to that. Yeah. Two. All right. What are we doing? Dear. All right. So here's our program. So if you wanted to be really sure on this, you could do declare dash I, RV equals 3. And then I wonder if that's going to change our output. Nope, it didn't. It just showed how it was declared. That's interesting. Dash P shows how it was declared. That is super cool. Yeah, I like that a lot. That shows it was an integer. What's dash dash about? Oh, that just, I don't know what that means. I don't know what to. Anyway, so if you want to do the same thing inside of this is something about Bash that a lot of people don't know. Bash has locally scoped variables. All right, so let's talk about that for a second. All right, let's talk about that. Let's get rid of exit RV and all that, the return value. Let's actually just use variables, and this will be good for today. Let's do variable scope, and we did the binary thing, and we can keep going. So let's say I have name equals Rob, right? And by the way, what happens if I do this? Anybody want to guess? What's going to happen? What happens, my friends? What did I do wrong? If you don't know what you did wrong, you can shell check and it'll tell you. Just everything follow the past plain arguments instead of interpreted options. Yeah. Shell, so that makes it shell check. You say you don't have us around and you want to know what you did wrong, you can say, oh, I need quotes around it. Again, use shell check. So put double quotes around it, right? Now run it. Shell check is still not passing because I didn't quote my name. It's going to use expansion because there's a space in there. So we'll do that. And we'll do that. Shell check passes, .03. And we get the name. Okay. So I just wanted to double check with you to make sure. When in doubt, just quote it out. Put quotes around it. All right. Now, what happens if I want to echo it down here? Right? I put it down there inside of this little subroutine. I'm calling it a subroutine. They call it a function, but I'm calling it a subroutine. A subroutine is just, I want to go run these lines, right? And I'm going to run it down here and nothing. Why? Anybody remember why that's happening? This is the end of the file right here, right? End of file. So why isn't it running, my friends? Why is it running? So I define this subroutine function, and it's actually not even just not an export. It's not even working at all, right? Now, this is a little bit tricky because no function call, right? Because the name of the command is the same name as the function. And that's just a convention I do a lot. But we can put dir3 here, and that says, okay, now run it, right? And we can go this, and we say, oh, look, it ran, right? And it did the whole little find thing and all that. All right, so now what happens if I change the name in here? Okay, what if I change the name? What if I say name equals Doris, right? So what is going to happen? Nothing, right? Nothing happens because we're echoing it before that. If I echo it after that, it's gonna, let's just comment this out for now. Actually, let's make a new one. Let's say greet. I mean, this should be a different program, but I'm kind of doing this fast. Let's say greet. Let's say echo hello, and we use variables instead of printf, which we learned last week. Hello name. Okay. We'll move this stuff. We'll leave dir3 alone for now. Let's just call greet instead. Okay, so now what? If I call greet, hello Rob Milstein, right? If I change it right here, if I say name equals Doris, and I run it, I get hello Doris. Why? Because it got changed, right? But after the program runs, if I echo down here, what do you think this is going to say? What do you think? What do you think echo name is going to say down here? And this was kind of intuitive and all is good, right? It's still remember Doris, right? All right, but what about this? What if, of course, if I change it here, right, that, you know, is going to just change it. That's going to change it. It's going to say, okay, I changed it both places, right? What if I put it down here? What if I change it there? Then what? Then what's it going to do? It's going to put hello what? Hello Rob, right? And then it's going to print Doris as name because it changed the name, right? But watch this. What happens if I say local name? And then I run it. Uh-oh. What happened? Probably what you wanted to, right? And if you've done any Python or JavaScript, you know what just happened. So by putting the local keyword, this is a bash-ism. This is a bash thing. Z-Shell has this too. POSIX does not have this. It's really annoying. Doris got lost. Oh no. So Doris is local here. Now here's what's crazy. If I put it here, yeah, right? Okay, so I'm glad you used that word. Scope is what we're talking about. All right. Scope in coding is almost always associated with the block. All right. So, grok, code block, and scope, and variable scope. It's not really even variable. It's just scope because constants are also, actually, no, constants don't have a scope. All right, so a variable, we already talked about this, means it can vary, it can be changed. So what we have here, and I'm glad Bash has this because, you know, the Python and other languages have this too. So we have scope in Bash. If you put local in front of the name, that says that I want to use this variable called name inside of this greet function. And what do you mean if Rob is local? I mean, and so what this does is it's something called masking it. Okay. So as far as the greet function, subroutine, program, whatever you want to call it, subprogram is concerned, when it sees local name equals Doris, it masks the global and it changes it, but it only changes it for the scope of everything inside of these brackets. Okay. It doesn't change it outside of that. And we would call this a global. And usually if you want to do this right, you should put declare here. Right. You don't have to, but if you want to kind of do that, by the way, if you try local up here, it'll yell at you. It'll say, no, you're trying to use that outside of but other than that, that's the same thing. Declare and local are literally documented in the same block in the man page. So they are bashisms that Shell does not have. And speaking of that, function, you could put function here if you want. I don't. I find that redundant and useless. There is a reason to do that though, because if you wanted to just grep out all of the functions in your code, you could definitely look for them that way. But you could also just look for anything that has a parentheses after this. These parentheses don't ever have anything in them. That's just the way you identify a subroutine or a function. Name with Rob is local, but if you call it local, it will still behave like a global. Well, before now, if I do it, watch. If I echo the name before I shadow it, it's called. Oh gosh, that's cool. Oh, base, I base. Oh, you set the input base as well. Oh, I didn't know you could set the input base. Okay, so here we see that the first hello is using the global. It's using this one. And then this one shadows the global and it uses the internal one. And then after you leave here, yes, you can pass function parameters, but they're not up here. It's okay. I'm going to do it next. We're going to do that next. Okay. So here we have a function, but I want the takeaway here is local variable scope shadows the global variable scope. Global means that it applies to anything from that point on, right? And there's no hoisting like JavaScript or anything like that. Other languages, sometimes you can declare a variable at the bottom of the file and it relates to the entire program. And there's nothing like that going on here. It's all very much one line at a time. So if you got the top line, this means everything after this name is always going to be there, right? And you can unset it. I think it's unset. Yeah. If you want to like empty it out, I'm pretty sure you can unset it. Yep, there you go. Unset just gets rid of it, right? So let's add those to our list. So we have return, we have declare, we have local, and we have unset. So if you want to truly unset a variable, people will make the mistake all the time of doing this. That does not unset the variable. Nope. It does not. It does not unset the variable. All that does is empty it out. So it has nothing in it, but it's still there, right? If you want to get rid of a variable, you do unset. Same goes for a global as well. Okay. So that's good. And I mean, this has been a quick thing about scope. So somebody mentioned arguments. We talked about arguments and parameters last time. What's the difference between argument and parameter as a review? What is the difference between an argument and a parameter? We should actually change this. I'm going to copy dir3 to greet. And then I'll make dir3 again. I'll get rid of this crap and leave it here. So y'all have something to refer to. Okay, so now we do dir3. And we get what? Let's go play with greet now and keep them separate, shall we? Get rid of this and get rid of this and get rid of this. All right. Param is a variable that you pass when you declare. Arg is the value that you pass to the function. Yeah, I wouldn't use the word pass for a parameter. Parameter is what, defining something that can be passed. And the argument is the actual value that's passed. I mean, it's semantics, but So just we covered that last week. I just want to make sure. And so here we have greet, right? And let's go ahead and run greet again. So you can just do C for that too if you want. And if you want, here's something fun. Watch this. You ready? So you can do watch dash n 5 seconds /greet. And now it will just run greet every 5 seconds. I don't have to keep typing it. Did you see that? I'm going to put that here. It's a really fun thing. It's like a nice way to, you can actually do iNotify, which is even better. And then if the file changes, it runs. Actually, what is that one? What's the other one? What's the other one? Let's do that one. What is it? I forgot. Entra. Yes, thank you. I have to look it up because I don't use it that much. Run arbitrary commands when the file changes. Okay, so entr /greet. Damn. Oh, that's right. You have to do the find thing. You have to do the find thing. Yeah. Watch df. How could you do it? Don't you have to do the find? There's like some sneaky thing you have to do. I don't remember it. I mean, there we go. Okay. So yeah. There we go. We should probably have it clear though too, huh? So let's actually have it clear the screen. There we go. Hello, Doris. And then we can change Doris to Rob. Hello, Rob. All right, so watch and ENTR. Oopsie. ENTR is awesome because it's not just running all the time. It's a little bit trickier, but anyway, so we got clear, we got a greet, and we're calling it right. Now it didn't get down here though. Why is it just doing hello Rob and not getting to here? I wonder. Why isn't it printing that? The name is still single quotes. Uh-oh. Uh-oh. What happened here, my friends? There's no name. Why? Why isn't there a name? Because the name is up here. Right? We declared it and we unset it. We kind of like threw it away. So let's get rid of this. And now we get it. Right? I'll get rid of my last name in there. You don't need that, I guess. Let's move this one down to Doris. And then we get the same thing. We get hello Doris. The name is still Rob. How about we do the global. All right, so the global name is whatever. The global is Rob. You can do that, but I don't recommend it necessarily if you can get away with it. You cannot mix Python and Bash, no. You only have one shebang line per file, and it's always the first line. Why is it still expanding name? That's a good question. Why? You're loving my stream? Hey, Roman, thank you for saying so. So why is it doing that? Why is it expanding that? That's a good question. Somebody want to help Hilho out there? Somebody want to try and answer there? Is this string really single quoted? I mean, if you look, the colors are kind of a giveaway. You could run Python or Go from within a bash script. You have to call a separate script though that we would write. Yeah, yes. We've already demonstrated that. We're just dealing with functions right now, but yes, you absolutely can do that. We're still in double quotes, right? Let's for grins, let's change it. Okay, let's just change this. Let's say, we want to change it to this. Now the colors are kind of giving away what's going to happen here. What's going to happen here now? The color coding is the color syntax hiding. Yeah, duct tape. So here you see the difference? Now, it's super important that you understand that this is a bash specific thing. Python does not see a difference between single and double quotes. There's been a lot of people that come to Python from bash and they're expecting the same behavior. It does not happen that way. All right. In fact, there's, backticks and stuff like that. And when we get to Go, there's backticks as well, string literals and JavaScript. There's lots of different ways to represent a string. But in bash, there's two fundamental ways that we talked about. The double quoted one. Now, this is kind of weird. Look at that one. This actually works, but it didn't do what you thought it did. You see that it doesn't have the quotes in it? Why? What did it do? This actually did something really, really, really weird. This did something really weird. And this is exactly the same as this. Echo the global name is echo name, echo that. That is exactly what it did. And by the way, it see how it lost the quotes? I mean, it still prints something up, but it's not doing anywhere. It's very, very dangerous, actually, because this is what it's actually doing. And see how this one is unquoted? So if, again, what do we do when we want to have something be safe? What do we do? Right? How would we know if our code was safe? And we can sleep at night. We run shell check and it says, you forgot to quote name. Wow, look at how good that error, man. I love shell check. I am so happy to be paying them money every month. I pay shell check the project about $5 every month because I love their project so much. Look at how verbose that error is. The surrounding quotes actually unquote this, remove or escape them. That is the specific thing to do. It's not some generic thing. It even gives you a link to a full explanation of how to do it. If you're not using shell check, you need to start. I don't know how many times I have to say that. So I'm like, okay, well, I'll do the right thing then. What if we had double quotes in our string? Yep. And we need to escape them. And the magical escape character is backtick. And you see the colors are helping us here. People say that colors are juvenile. That's quoting Rob Pike, are full of crap. Because syntax color highlighting is too bad if you're colorblind. This is a very, very positive use of color. It really drives me crazy when I hear people talk like that. I don't like it. Color has a place. A very, very important place. You see here, now we got our quotes, right? Now, this is interesting. So let's say we were going to do single quotes, right? Go back to our single quotes again. Let's go back to single quotes. Now, this is where things get a little jank. All right? Let's say we look at that. There's no escaping a double quote. This is actually something I've struggled with in the past. There's no escaping a single quote. And so if you want to do this, and sometimes you do actually want to have a single quote, right? So let's say we wanted to put like, I don't know, something like that, right? To do this kind of thing, you'll see people do this kind of thing. And this looks very weird, but and it puts an extra space. And this is going to start checking your bash knowledge. Just when you think you understand the quotes, yeah. So, do you see what this is doing? So this is exactly the same as, yeah. Basically, what I'm saying is, if you need to, and I do all the time, right? So if the global the global's name is, right? You can't do it. You can't escape it. You can't, as far as I know, you can't escape it. If anybody knows how to do that, please let me know, because I have never, ever figured that out. I think, can you use 2? I don't think you can. No. You can't. I have never figured that out. I'm sure somebody knows that. I can't. I have never. So, and I know a lot of people that don't know that. No, we're not doing that. It's not going to work, because those are escapes. It's just going to put an ampersand. No, good try though. Good try. This is not JavaScript. Try 3. I mean, yeah, no. I honestly, I do not think it's possible.
Gussie?
Yeah. So, if you want to do this is why I use double quotes. But then things get really, really hard if you have slashes in there. So now you're like trying to put a path in here with backslashes in it. So let's say you're on Windows, for example. This is why Windows is so bad. So like if you're on Windows, you know, escaping the quote is like one thing. Whoops. But if you like, you know, the global's name is blah, and then you like put like a path. So let's like put a path. Let's say home on Windows is /home /extra, right? Well, now you got backslashes in there, so now you have to escape all the backslashes, right? And God help you if you like are joining strings that have backslashes in them. So it gets messy, particularly when you're like doing substitutions and stuff that have, you know, slashes in them. We're going off on that too much. I hopefully this has been useful. Let's go back to our variable scope, okay? So, and we'll do argument assignment and how to pass arguments to functions, and we'll call it a day. And then you'll have functions and variables down. And that's the only thing really left to cover in Bash after that, my friends, is conditionals. Pretty much. Conditional evaluation, if then, logical stuff. And that's it. Then you're done. You got all your Bash that you need. And it's just pasting things together. So we don't have conditionals yet. We'll cover that. We'll start with that next week. But let's go ahead and finish up functions, or, you know, passing stuff into this. So concatenates the first. Yep. Rishi, that's exactly what I was doing earlier. I was trying to show that, yeah, you'd have to like do the first one and then concatenate it and then do a thing. Yeah. That's true too, but that will give you an error. You can't do that. No, you can't do that because it'll escape it. Anyway, so let's go back to this one here. We'll go back to single quotes here. And there. Okay. So, and some people would say you should put brackets around this too. If there's any question about the name, like if there's something else here, then you can put the brackets around them. You don't normally need that though. MPV with high latency. Oh, that's okay. Sorry about that, my friend. All right, so here we go. Let's do this. So we got global name is whatever, right? And so what have we demonstrated? So the global stayed even though local got changed. Well, what if I want to make the greeting something new every time, right? So there is a special variable in shell called $1. All right, and $1 is the first argument, the first parameter, $1. And if you want to read about these, you can read his arguments. Man help, man bash, special variables. Covered curl already. Yeah, we did a little bit of curl. We'll come back to curl later. Curl is kind of its own thing. Yeah. Parameter variables. Yes. Special. This is under special. Here we go. So special. I'm searching for special. Special. There we go. Special parameters. No, we're not going to do those yet. I guess we are going to do those. Okay, so shell variables. Here we go. So here's all the special variables. And this is when we start to lose people. Because the positional parameters and the special parameters and stuff like that, they start to look weird. So we already know one, right? What's one of the special ones we already know? So what is this one? What does that mean? What is that? What is that? That is the exit code or the return status of the last function. It's either exit code or return status if it's a function. It's either or. That's why I keep getting messed up. All right. So that's the return value. Now that tells you if it's true or false. That's going to become super important when we do conditionals next week. Okay. We haven't done that yet. And we haven't done math and all that. We're going to do all that next week. But this is good coverage up front. So make sure you understand. It's our first one. All right. Now, there's another couple of ones. There's some of the really important ones. Okay. So one, right? And $2, etc. Okay. These are the positional parameters with no name. So if you've gotten used to named parameters from other languages, too bad, but it's okay because you can kind of do something similar. All right. And we're not going to talk about the globs yet. That's going to screw everybody up. So let's skip that for now. So we'll go back here. So let's say I want to pass in the name. So instead of having it be Doris, I have it be $1. All right. Now I just did a problem there. I'm going to run it through shell check, and I'm doing it on purpose so you can see. So now it's going to say hello name equals blah, blah, blah. Right. I say that. Oh, look at this. Greet doesn't got anything. So I can greet Doris. Hey, it did it. All right. See what it did? So I added $1. That means it's the first thing separated by white space, right? So if I want to do Doris Kapner, it worked, but it didn't quite work, did it? And it didn't even give me an error. Once again, shell check to the rescue. What happened here, guys, people? What happened? Why did it say Doris? Because in our command line, the default is white space splitting on white space. So that's technically 2 parameters. I mean, I could do this. I could do last equals 2 IFS. Yeah, the input field separator, which they don't know about yet, but good call. It's the input field separator, otherwise known as the thing we split on, and by default it is space. Okay, it's just space. If we do 2, now something cool here, I could say hello, name / last, and we get Doris Kapner, right? Because it's 2 separate parameters. Doris is the first argument, Kapner is the second argument, and name is the variable that receives the first parameter, the first argument. This is the first and the second. So even though we have 1 and 2, we can actually name them if we want. And we can actually combine them into 1 if we want. Now, I have mixed feelings on this, but you can do this, okay? As I'm demonstrating, you can do this. Then we can change this to first, right? And because it's all local, and we still get the same behavior. All right. Yeah. Shell check is going to scream at me. Can anybody guess what shell check is going to scream at me about? Shell check is going to have a fun day with me. It's like, oh my God, what are you doing? Yeah, you could do that too. You could do that too. All right. I'm going to show you why not to do that though. So let's see what shell check has to say about this. Shell check. I mean, it's working, right? My code's working. What could possibly be wrong? It's actually kind of okay with it, right? Now, if I else, let's try that. It still passed. Shit. That's interesting. You know why I did that? You know why it passed? Because these don't need to be quoted. This is this is the overzealous POSIX people among us, myself and Hap included, would normally put quotes around this $1. But you don't have to. It automatically does that. It did it down here. So as long as there's quotes around this, it's fine. If I do this, though, it's going to freak out. Should freak out. Yeah. It's like, can't do that. Because why? Because it said, did you mean echo hello first last? Double quoted prevent globbing. Right? So, okay. Now, the comment was made, why don't we just use $1 and just forget the other stuff? We can totally do that. but I'm going to tell you why I prefer to do the named way, and because of parameter expansion. So let's go like here. We do this. Whoops. So we still get it entered. Hello, Doris Kapner, blah, blah, blah. Everything's working fine. All right. Last thing. Let's say we want the default. So what if there's no name, right? We want to give it a default value, which is something that's hard to do in other languages. Depending on the language, some of them are more hard to. Let's say somebody just wants to put a greeting and we want to say hello there, right? As a default. How do we do that? Now, this is where parameter expansion comes in, and we are only going to touch the tip of the iceberg on parameter expansion. Parameter expansion, in my opinion, is the most powerful part of Bash. Hands down. Regular expression matching is pretty damn good in the conditionals, but parameter expansion is going to save you from 10 sed and awk calls. So, and this is something that's going to take quite a bit of reading on your part because it's hard to grok. It is hard to grok. You have to look it up a lot. But I just want to, for the veterans out there, I want to make sure you know about it. But I suggest a thorough, particularly if you've been doing Bash for any amount of time, I suggest a thorough reading of the parameter expansion section. Because you'll never use sed and tr again after you do. Because it'll just be so much better, particularly in your scripts. You might use them on the command line when you're in a pipeline. That makes more sense when you're doing a real-time pipeline. But when you're writing a script, if you're shelling out just for 5 different seds, awks, and trs, you got to be fired, in my opinion. I'm not even exaggerating. That's not hyperbole. I see this all the time, and I'm like, really? Really? You setted that whole file just for that one thing when you could have just done a parameter expansion? Because nobody knows it. All right, so parameter expansion, conditional parameters, we covered that. The special parameters. So we talked about 1 and 2, right? Shell variables. We're not gonna cover those right now. There's a bunch of them. Time formatting. We're not gonna cover that. Parameter expansion, tilde expansion, brace expansion, parameter expansion. About shell check. Yeah, shell check. To be fair, I only learned about it about 2 years ago when I started streaming. Yeah, it's a relatively new build, new thing. So yeah, anybody running any enterprise code that's not getting run through shell check at this point is pretty much irresponsible. I don't mean to sound mean, but it is such a mandatory thing. There are so many problems with shell code that if you're not doing it, shell, POSIX, bash, and all that. So anyway, and we know that. I mean, anybody who's been around the block knows how dangerous shell code can be. So you need to be running it through shell check. So here we go. Parameter, right? The value of the parameter is substituted. So the brace is required with the parameter's positional parameter with 1 or more digits, or when the parameter is followed by a character which is not to be interpreted as part of the parameter is a shell parameter. All right. So parameter expansion has brackets. If you just put the brackets, I mean, we already know about brackets, right? Because if you want to disambiguate something, that's how you do it, right? If I wanted to have, I don't know why, but if I wanted to have a 1 after the name, right? I mean, look at down here what it's doing. See, hello, Rob 1, right? Then I would have to disambiguate it with braces anyway. So that's already a part of variableness. But if you put something in here, right, you can do all kinds of things. So I'm just going to throw you a couple easy stuff. So let's do all caps. All right, or I think that's all lowercase. So if I do greet Rob. All right, that's all lowercase. So what if I want to do initial caps? Initial cap. Oops, I was going too fast. Let's do this. There we go. Look, hello, Rob, right? Hello, Rob. Right, special bash script. I mean, I don't know. I would personally run it there. Make sure you learn about shell check. There's ways to turn off some of the overzealous things that it does. Now I get Rob Muehlstein. It does an initial cap. See, so this is just the beginning of parameter expansion, right? You can transform the things that are coming in. And there's lowercase, there's uppercase, there's things like that. But more importantly, there's things like default values. Okay, so we can get rid of this. And you see we have nothing here. We have hello, right? We want 1 to default to there. So let's go see what we can think of here. And there's like so much to read here. I don't know how to run, especially after executing every bash script. Well, I mean, not every, while you're developing it. While you're developing it. You definitely could. I mean, you could actually work it into our little ENTR thing if you wanted to, or you could just run it by hand. I just do it before. You don't have to do it all during your development. It's kind of annoying, but before your final deployment, I would definitely do it. I call them parameter expansions. So here we go. Use default values. If parameter is unset or null, the expansion of word is substituted. Otherwise, the value of parameter is substituted. Assign default values. This is use default values. If the parameter is unset or null, the expansion of word is assigned to parameter. The value of parameter is then substituted. So this is important because this doesn't just take the value. This actually assigns the value to the thing in addition to that. And display error if null or set. All right. So if we go here and we say, we're going to do this one, right? So this, if we just do this one, right? What do we get? Hello there, right? We can put a dot there. Hello there, right? And we could say, Rob. Hello, Rob, right? But see, if we do it that way and then we echo $1, does $1 get changed? No. Okay. We don't. If we do equals, then it changes the value. It should change the value. Why is it not changing the value? It's supposed to change the value. Did I get that wrong? The value of parameter is then, oh, no. That's because we didn't set the, okay, I know why. Because we didn't do the assignment. Yeah. I don't know if I got that right. But this is why I do name. Okay, so I do local name equals 1, right? Colon there. And then we change this to be name. And we don't need any disambiguation, so it should be fine. And what do we get? We get hello, Rob. Right? And you're setting it. Was I? Because I'm setting it. Oh, right. I was setting it. Thank you. You caught it. You caught it. Yeah, let me go back. I see. I want to catch myself here. Thank you for that. This is why I have you. Yeah. So this one is going to actually change the value of 1 to there after that. Right? And then down here, if I thought I had it right. I was passing a value. Oh, whoops. What? What did I do wrong? Can I say the level's name is Rob? What am I doing wrong? It doesn't work with positional parameters. Does it say that? Thank you, LBG. Does it say that? Okay, well, I don't, that's why I've never hit it. Positional parameters are special. That's why I don't use them. So somebody was asking me why not use $1. That's why. All right. I don't do that. This is what I do. I use named parameters always. And then I use the parameter expansion. And honestly, I mix up dash and equals all the time because they don't matter. I don't think they matter when you use them this way. Right? So right? So hello there. Hello first, comma last. There's actually an empty space after that, which is probably bad. I mean, you could mess with it. But so it says hello there. And if I put Rob, it should do Rob. And then we get hello Rob. Right? Empty, we get there. What if I do this? Oh, how about that one? How about that one, my friends? I actually passed an argument, but the argument, we're going to get into the number of arguments and all that next week, probably. We don't have time today. but the number of arguments is still 1, and that actually has a number. I think it's this, right? Yep. So I found a number of arguments explicitly assigned. I mean, you can do that too, right? So, yeah. I mean, there's many ways to do it. You can ask how many arguments you have and blah, blah, blah. I found 1 argument. So even though there's a blank here, I still have 1 argument. Otherwise, I have 0 arguments, right? So dollar number is another thing we learned about. So dollar number is how many did I get? How many arguments do I have? And you can use that to check to see if there was any arguments passed. That's important because somebody might actually want to pass an argument that is a blank and do it that way. I usually use this. I think there's another way to do this though. If I remember right, you can do this. Can it be sent this way? Yeah. There's a trick you can do. Actually, it's in my Z program. Yeah. So this is kind of an interesting way to assign default. The colon is the non-statement. If you're going to do any of this parameter expansion, you can do this, and this will evaluate it. So this says if pager's not set, set it. This is basically setting default environment variables, and it's a trick that I saw on the internet, and I love it. It's also important to note that parameter expansion has its own quoted quote scope, so you can put double quotes in there. You don't have to escape them. That's same thing for command parameters. So it's kind of fun. If you want to set defaults for all of your environment variables in case, but this says, hey, if the environment variable was set, don't set it. But if it wasn't set, set it to something. And that's a very, very, very common thing to want. Pager is more readable to you. I don't know if it's even the same. That won't change the value though. Oh, no, that will change the value, but you'll just repeat pager twice. Yeah, I'm not a fan. If you want to do that, fine. I don't. So, yeah, more readable. It's also more repetitious. So anyway, I mean, I do that for my standard stuff. Anyway, up here, we'll go back to our one that we had, local name equals blah, blah, blah. And this would be a dash. And so, yeah, it's not working. What am I doing wrong? Oh, first. We're about done here with our descriptor. Okay, so hello there. I mean, I think this covers it. There's only 2 more things that I'm going to cover really quickly. And one of them is, yeah, so arg8, but not arg317 is the best way to do that. You want to specify arg8, but not 1 through 7. You'd have to put a bunch of blanks in there. Yeah. You'd have to do, so let's say 4, right? 1, 2, 3, 4, 5. So echo 5. So you'd have to put those in there. You can use shift. Yeah, shift is really cool too. I mean, we should probably leave the rest for next time because there's a bunch of other things we can do with parameters coming in. Shift is really great. So shift will read one off, and then you can, if you know that you've got several of them. There's many ways to deal with parameters. In fact, one of the best reasons to use bash is all the powerful things you can do with parameter expansion and parameter reads, like people have been talking about. And of course, we don't return anything from here, but let's try that. So last thing to round out the day, let's go ahead and return. Let's say, okay, what if we wanted to say, what if we want to be more draconian about it, right? I want to say, I could say, we haven't done if statements yet, but we will. So we could say if, I'm just going to cheat here. So hash. I'm kind of this is kind of a preview for next week. If this is less than 1, 2, no 1. If it's less than 1, then return 1. All right, so it failed, right? And we called it down here, but let's do this. Let's say echo $that. We can see the return code was actually 1, right? And you can actually do some short circuit stuff with this. We haven't done these yet. We're going to. We say and echo, which is always true. This is called short circuit logic. Usage, whatever, less than. Did I say less than? If the number is less than 1, thank you. If the number is less than 1 and echo usage return 1. What am I doing wrong? Oh, right. The derp. There we go. All right. So usage, greet, first, last. Right. So, and if you want, you could echo to standard out. Yeah, you could do, we don't, to, is it dollar, is it to 2? No, we do echo. There's a switch for echo, but it's not POSIX compliant. So 1 goes to 2. Did I get that? Yeah, there we go. So now it's not cluttering up stuff. Nobody does that though. They don't do that. They should, but they don't. So yeah. So that says the error that we want, right? And then we say Rob, and then we're fine. Actually, we forgot to assign our stuff. So we could say, we're done. I'm like just geeking out. Local first equals equals 1, right? There's an easier way to do this. I'm really trying hard not to do it that way. First, last equals 2. And those don't need to be quoted, which is weird. Right? So, all right. Yep. No. So these up here, this is standard in and standard out. This has nothing to do with the parameters. Yeah. And we could do shift and stuff. So that's what I'm trying to say is you could get, interesting with this. This is a short form of an if statement, short circuit logic. We could use all the time in shell because it's super convenient. What happens is if any of these conditions fail, it stops. And that's it. Right. So if this is true, then it evaluates the next thing, and the echo is always true. Therefore, it automatically returns the next thing, which returns 1, which doesn't come back. And so you can get away with echo for usage if you want to do that. It's kind of a cheaty way to do it. But if you wrote this out as an if statement, it would be like, it's like 5 lines, 6 lines. We'll do more of that next week. So that's kind of a preview of what to do. With bash scripting. This is math. You should be doing this a lot. You should never do math in single quotes, in single brackets. If you're doing that, please stay tuned for next week. I'm going to shoot that down big time, and why you should never use it. People do all the time. I still think you should never use it, and I'll make my case next week. And that's it. That's going to be it for today. Who should we go raid? Should we go raid somebody fun? Who's on that we could raid? So if you're watching YouTube, go ahead and stop watching now. We'll see you next week. I will be, however, doing a bunch of IRL streaming today. It's a beautiful day out. I don't know if I'm going to be running. I think I might actually go try some running today with my rig, which I haven't done yet. I don't know yet though. I might wait and see. Yeah, and I'll be in the IRLs and we can talk. I'm trying to look for some streamers. We need somebody from software to. Oh, Zorch is on. He's playing games though. TD Linux is streaming. Who is that? Artisanal dot matrix printing. Oh, I'm totally rating this dude. I'm totally rating this. He's doing top matrix printing. All right, my friends. Thank you. Have a good time. I'll post this up for later. All right. Make sure to tell him hello for me if I know. We'll see you in Irvis. This is super cool. Bye.